morning all. A warm welcome to one and all present here for the session on ECE and allied streams of the third edition of How to Execute Successful B.Tech Projects organized by IEEE PES Kerala Chapter and co-hosted by IEEE PES SBCs of JCET and SCTCE. First and foremost, I would like to welcome our honored chief guest for the session, Engineer Ajit Gopi, to this auspicious occasion. Engineer Ajit Gopi now serves as the Vice Chair of IEEE PES Kerala Chapter and as the Program Officer in ANERT. I welcome you, sir.
Thank you very much.
Thank you, sir. Now, I welcome Professor Deepa A.K., Chapter Advisor of IEEE PES SBC SCT to facilitate the gathering.
Yeah, I think it's after Ajit sir's welcome address. Ajit sir, can you please take over this session?
Yeah. Am I audible?
Yes, sir, you are audible.
Okay. So, first of all, I would like to congratulate the students and IEEE PES student coordinator and team, and all the volunteers for IEEE PES volunteers for taking up this very needy or wonderful effort from you. This is actually now the need of the time, because I think the next batch of B.Tech students are, I think the current batch, the results have come out now for the last batch, and the other batch in the pipeline for preparing the project. So it's a nice occasion to start with. It's actually, I've been training people, I've been supporting B.Tech and M.Tech students from my organization, ANERT, for the last several years. So, a part of IEEE PES also, a couple of years back, we had very good sessions under the chairmanship of Professor VKD sir. We had some brainstorming sessions to discuss about how should the B.Tech projects move forward. What are the problems we can point out for B.Tech and M.Tech projects? So I remember that was very nice session. We listed a lot of projects from which is something like the problems with the industry, and the need for the communities, and the solutions needed for the local people. So I should say that this is a very needy one. So for the last several years, I told you that I have been guiding people from my organization. So one thing I found was like, see, most of the student projects are coming with templates. I should say it's templates. Like maybe some projects, some IEEE papers they are referring, and from the IEEE papers, they will follow the same paper or same concept, and some alternate stuff they will introduce, and somehow they will complete it from the templates. So I have been deferring this idea, or the way it is executed. So most of the students who came for my guidance, I was advising that, can we do something for the community? Can we do something for the society? So it should touch the community. It should be something like needy for the industry. So industry is facing a lot of problems, especially after the revolutions happening in the grid, revolutions happening in the renewable energy industry. We need a lot of young minds to contribute for that. Your guidance we need. Actually, the guidance from the students we need, because younger minds can contribute a lot. See, the challenge for the distributed energy generation is very high. It's happening around. A lot of blockchain projects are really happening in various parts of the world. So, as a society with a local self-government intervention, we know our Grama Panchayats are effectively handling COVID crisis. So we have that legacy of local self-governments. So it will be a great opportunity to mix local self-governments and your B.Tech projects along with the industry. So it should be a very nice blend to execute projects. So these are the ideas, my thoughts, because I'm not going to the your technical side of the conceptual side. I'm telling it should be something like that. So you cannot parallelly run. You have to mix with the community. You have to mix with the industry. You have to mix with the society. See, the idea of a sustainable circular society is in a very high in a very high notification now all over the world. Recently, I participated in a very high event, virtual summit by Denmark Technical University. It was a virtual event for sustainable circular society. So it's all touching the developing world people know how to move with this pandemic, how to alleviate poverty, how to get the what you call the digital literacy around, how to remove the energy poverty. In Africa, we could see that it's still a dark country in terms of energy perspective. We still have a lot of unelectrified villages in the state, in the country. So though we are 100% electrified in terms of census villages, just in Kerala, more than 50,000 villages in India is still unelectrified because of the remoteness. And things like artificial intelligence and machine learning is coming for the monitoring, remote monitoring and operation and maintenance of bigger solar power plants. 2 gigawatt single power plant is happening now. The Pavagada solar power plant in Karnataka is 2050 megawatt. Recently, another project came in Andhra Pradesh that is 1 gigawatt. So for this huge facilities, we need a lot of intelligence from you guys. It can be something like a smart cleaning system for solar modules. It can be something like a drone-based monitoring of drone-based monitoring and utilizing the pictures, combining the Internet of Things and AI to get real-time data to analyze which inverter is faulty. And as I mentioned earlier, blockchain is revolutionizing our grid. People are becoming like, no, we are not being consumers. We are becoming prosumers. We are producing our energy and we are consuming it in our energy. So things like, see, as we have records for the land document, the previous records will be verified for when we go for loan. The things like the hash identification of blockchain is important when we go for the blockchain mode of peer-to-peer distribution of energy. So great opportunity with the students, especially with the triple computer science students, electronics and communication students to take up this challenge. We need smart solutions. We need smart solutions to monitor everything. We should have information at our mobile or a handful device. So this is very important in a world where this transformation of energy sources is happening. We are moving to a decarbonized world. We are moving to a renewable economy. So this is the right time that you're taking up this event. It's very innovative. Like this, if in fact, the role of PES is very important because we are the people who should define this. We should define this. We should design this. We should innovate students. We should guide students, giving ideas, giving our contributions. So that the projects, the B.Tech projects will be something like the project with the without the project going on site and the actual real situation is going on the other side. So I need to make it something like blend together with the society, blend together with the industry, blend together with the community, blend together with the academia. So it should suit to the needs of our society and of our community. So a great event. I would like to again congratulate all the team members and leaders and volunteers, PS volunteers, for taking up this initiative. So my best wishes for this event. It will be a great event in the history of PES Kerala Chapter because it's something very apt, I should say. So thank you for having me, and congratulations to all the PS volunteers and students who are attending the event. Thank you.
Thank you, sir. Now I'll welcome Professor Deepa AK, Chapter Advisor of IEEE PES SBC SCT, to felicitate the gathering.
Yes, you are audible, but the voice is feeble.
Okay. Good morning to all. I really feel happy to be a part of the event, How to Execute a Successful B.Tech Project 3.0, Society Chapter of IEEE Kerala section. The previous editions of the events are successful and really benefited to the students. Currently, Society Chapter of Kerala section organizes a lot of events similar to this, which directly helps the students to improve their skills. First of all, I congratulate the team, Soher sir and team, and a special thanks to RNND Society for providing us an opportunity to co-host the event today. In my opinion, actually, we got an eminent faculty, Dr. Anoop C S from IAST, to handle the session. Sir, it is lucky to hear from you. I experienced it during my FDPs. Thank you, sir, for joining with us. I'm sure that the participants will have some takeaway from this event, and it will really benefit. My request to the participants is to really utilize this opportunity to interact with such an eminent personality. And a real congratulations to all the entire technology team for organizing this events and the participants. Wishing you all success. Thank you.
Thank you, ma'am. Assistant Professor Sanish V.S., Chapter Advisor of IEEE PES SBC JCET, was also supposed to join us today. Unfortunately, he couldn't make it. I would like to welcome him in his absentia. Now, I would like to welcome Ms. Sasha S., Secretary of IEEE PES SBC JCET, to take over the platform and welcome our presenter for the session.
Hello, am I audible?
Yes, you are audible.
Thank you. He graduated in Applied Electronics and Instrumentation from CET and did his PhD in Electrical Engineering from IIT Madras. He started his career as engineer network management systems in Nokia Siemens Network. Later, he served as a postdoctoral fellow in IIT Madras and assistant professor in the Department of Electrical Engineering at IIT Kharagpur. He has also offered several theory courses at IIT Madras and IIST Trivandrum. Currently, he is an associate professor in the Department of Avionics at Indian Institute of Space Science and Technology, Trivandrum, and is also serving as an associate editor, IEEE Transactions on Instrumentation and Measurement. He was a co-investigator of the research project on Advanced Retarding Potential Analyzer for Machine Ionospheric Studies and principal investigator of Reluctance Hall Effect based through Shaft Angular Position Sensors, Finite Element Studies and Development, IIST Fast Track Project. His notable achievements include Spot Award for Excellence Performance from Nokia Siemens Network in 2009, Institute Postdoctoral Award from IIT Madras in 2014, GE Edison Macathon Award in 2016, Outstanding Avionics Undergraduate Teacher Award in 2017, and Space Science Technology Excellence Certificate 2019 from Indian Institute of Space Science and Technology. With greatest pleasure, I welcome our today's distinguished resource person, Dr. Anoop C S, to take over the session. Sir, please.
Thank you for the nice words. So let me start off the presentation by just sharing the slides first. Hello, I hope my slides are visible. So thank you very much for inviting me to this talk. So I would like to share some of my experiences that I had while I was a student and some of the experiences while I had when I was guiding some B.Tech undergraduate students. So, I'm, as you told, I am working presently as an associate professor at the Department of Avionics, Trivandrum, IAST Trivandrum. Now, I had after completing BTech, if you see, I had 2 years of experience at Nokia Siemens Networks. Further, I went for PhD postdoctoral studies, and then, of course, I worked as an assistant professor at IIT Kharagpur for 2 years. Then, presently, I'm working at IAST. Now, all through the last decade, I have been working on various areas related to sensors, interface electronics, instrumentation, etc. So specifically, I have worked on topics like angular position sensors, through shaft angle sensors, capacitive sensors, biomedical systems. I'll be discussing about some of the biomedical systems in today's lecture. Then I've also worked on some advanced areas like retarding potential lasers, ultra low current measurement, etc. So here I'm just giving some snaps of the works which I've conducted. So you can see a through shaft angle sensor has been developed on the right hand side of this slide. So a biomedical automotive product has been developed. So this product has been developed by some of the UG students who had worked with me. I've also developed some kind of defectoscopes, which are used to find out the cracks or defects which are present in the case of metallic plates. Now, such metallic plates can be seen in aerofoils, welding industry, etc., etc. So, lastly, we are, as being a space institute, as I'm working in a space institute, I work also for space payloads and instruments which give valuable information about the Earth's or interplanetary environment. One such instrument is also shown here, that is the retarding potential analyzer. I hope I'm audible. Can one of you give a feedback so that?
Yes, sir, you are audible. It's perfect.
Thank you. Yeah. So in this retarding potential analyzer, the main challenge as an electronics engineer was to develop an ultra low current measurement unit whose resolution is as low as 0.1 picoampere, and the largest value to be measured was something like 100 nanoampere. So it was something like a ultra low current measurement with wide dynamic range. So we were able to successfully demonstrate the electronics. You can see the PCBs, printed circuit boards developed. And this instrument, this electronics was integrated within an instrument along with the sensor. And this was actually flown in one of the PSLV missions last year, 2019. And we were able to get very valuable information about the ionosphere distribution of the Earth. Now, in the course of all these projects, I have been guiding many B.Tech students. As I mentioned, this non-contact ECG on steering wheel was explicitly developed by some of the UG internship students. Now, if you come to this ultra low current measurement, again, students played a part. UG students played a part. They played a part in, for example, designing of the PCBs, testing of the PCBs, and some part of the design aspects as well. So I have been always kind of blessed and blessed to work with UG students. They have given me very good outputs most of the cases, and it is always a very good opportunity to work with UG students because we'll almost always get something new, because UG being young minds, as the IEEE Vice Chair just mentioned, being young minds, you will bring fresh energy and new thoughts to us, which will enable us to proceed further in our research as well as product development activities. So now coming to the talk, I am just following a set of I'm just discussing a set of topics. These topics include a broad overview of what I consider an UG student project. Then I would discuss about the motivation, why we should do a B.Tech project, and some guidelines regarding the project topic selection. And I will also discuss what would be the typical flow of events that happen in a usual B.Tech project. And then lastly, I would also like to define how can we define a successful project? Because this talk is basically titled as how to carry out B.Tech projects successfully. Then I would share 3 of my experiences which I had with my B.Tech students, case studies 1, 2, 3. So they are kind of varied experiences. Some of them are with B.Tech and final year projects. Some of them are internship project. Some of them are, one of them is actually a combination of both. So I will just go one by one. Now, when a UG student guidance, in my experience, final year project, official final year project, and other one is internship, short-time projects, hackathon collaborations, etc., etc. So I have been comfortable in both modes. So some students just do the final year project with me. Some students just do internship projects or short-term projects or whatever you call. Now, of late, I've seen that if you do internship or short-term project under a specific person, under a specific guide, and if you can do the final year project also with his or her guidance, you can get a very meaningful results or meaningful products from your entire B.Tech curriculum. It need not be the case. I mean, it needn't be always the case, but this is one observation which I had made over the about 60 or 70 UG students which I have guided. Now, going ahead. So I would also like to say that I have got very good appreciations in the form of awards recognition based on the UG project activities which was conducted. For instance, we got the GE Edison Mechathon Award in 2016 based on the UG project. This UG project was basically dealt with the development of a wheelchair for online health monitoring. So in this wheelchair, what we did is that we integrated different kinds of non-contact, non-intrusive sensors like electrocardiogram, magnetoplethysmogram, and the entire wheelchair gave valuable information about the vital parameters of the human body, like heart rate, respiration rate, blood pressure, etc. So we also, my students, of course, they played the major part. We also kind of participated in many competitions and won respectable recognitions. Now, apart from this recognitions and all, of late I have been carrying out serious publications, publication activities also based on UG projects. So this is also possible if you see. So if you see the slide number 8, you can see I have kind of published 2 international IEEE journals in very reputed places with the help of B.Tech students. You see, this is just to tell the different ways in which the B.Tech students have worked with me. So you see the student names which are highlighted in blue, like S Datta, A Anthony, B Sonata K. All these people were my B.Tech students. So for instance, S Datta did my his final year UG project with me. He was a student of IAST. And this Anthony, A Anthony, is actually a student of TKM College of Engineering, Kollam. She did internship with me for about 3 months, if I'm not wrong. Then these R Kumar and B Sonata K were again B.Tech under internship students, right, of IAST. Now, if you see, we have also published many number of international peer-reviewed conference papers based on the UG projects or internship topics. So you can see, I mean, there are many number of them. Some of them are like individual projects. Some of them are team projects. Like you can see, C5 is a team project. So these are some of the activities which we carried out at IAST. But I should say that this is not just institute dependent, because I had a similar experience. I have also published a similar reputed conference even when I was working with IIT Kharagpur as an assistant professor. So again, this is not institute dependent. This is not student dependent. This is not kind of guide dependent, because I know many other professors who publish and publish out of the UG project work, and they do patenting out of the UG project work. They get excellent awards, etc. So this is not also guide dependent. It is, I don't, and the whatever I have presented, it's quite clear that some of these publications or some of these awards are based on team projects. Some of them are based on individual projects, and sometimes people work together with the PhD students and get the publications. So there are many combinations in which the project has been so-called successful. So I believe that to get a successful or a meaningful output, the students should exhibit the right attitude and should persevere well, and they should do very good hard work, and then if with the right topic we can get excellent results, right? So this please understand that my motivation of presenting the last few slides was just to showcase that we can get excellent BTech project outputs or excellent products based on BTech projects, right? If you have good attitude and if you are able to work hard and persevere towards your goal. Okay. Now, next, I would also like to discuss on what should be the motivation why we should do for doing BTech projects. Of course, it's a course in our curriculum. It carries significant credits, but that is one motivation. Of course, that is understandable, but I would not say that is the main motivation, because the main motivation would be something else. See, I feel that the BTech projects give a very good opportunity for you to kind of practice and reiterate the theoretical concepts that you have learned over the previous semesters. Right? I mean, I believe, if I'm not wrong, in our universities and even in ISD and other institutes, we have at least 50 theoretical courses. So learning the theory is not enough. We have to practice them, and one way to practice them and assimilate the knowledge is to do practical projects. So these BTech projects give a very fantastic opportunity to revise and practice the theoretical concepts. Of course, when you revise the practical concepts, you will increase your knowledge base, right? That is obvious result of it. And then when you do a project, you'll be maybe carrying out that project with a professor who is having expertise in that specific field, or with an industry counterpart. So, I mean, you get a very good opportunity to interact with them, right? When you interact with them, you will not only inherit some of their knowledge, but also, more importantly, you will be able to understand the working style. I mean, like, if you may have a large amount of knowledge with you, but if you don't know how to work smartly, I believe that you are on slightly downside. So this is a very good point, very interesting point. I mean, when you work with a person, then you will get to know their working style, how punctual your guide is, or how how he or she listens to you. All these things you can get basically many social skills also. Now, many of the universities prefer to do team projects, right? The main projects or the final year projects are kind of team projects where a group of 3 or 4 people do their project. But maybe in some of our other universities, we like, for example, in IST, we tell that students have to do individual projects. That there is a reason for that. That is different. But as when I studied B.Tech, I also had done a team project where we had a group of 3. So this B.Tech project will help greatly to enhance the team skills. I mean, we will be able to understand each other, right, and know very well to work together in a team, right. This is very important for your future, aspirations and future, working environments. Now, see, B.Tech projects also gives us a opportunity to build a working system, hardware system or a software system. And if you build a system, such a working model, you will automatically take its own, responsibility and ownership. Now, this responsibility is a very important term. You may not appreciate or may not have appreciated it till now. See, when you go to an industry after your B.Tech or when you go for higher studies, you will have to take responsibility of some component, right, of that job, right? So if you practice that responsibility feeling now itself, it will be very easy for you to blend with the industry, right, or with a higher responsibility, higher studies, right? So this B.Tech projects will give us a very good opportunity again to take the responsibility of the project that you are trying to do. Now, see, B.Tech projects or any other project should be executed in a proper systematic procedure. So again, if you follow a systematic procedure in your final year project or undergraduate project or internship project, you will be also able to carry on with that systematic procedure in your future endeavors as well. No? Of course, based on the above points, we can see that if you do a good B.Tech project, needn't be successful. If you do a good B.Tech project, it will really ease out the gap between the academic theoretical environment and the real industry demands. For me, as when maybe 12 years back, when I joined Nokia Siemens Networks as a software engineer after completing B.Tech, I should say that my B.Tech project was very helpful, right? My B.Tech project was, I should say, was on one topic like intelligent robotic gripper. It's a control cum instrumentation topic. And I had joined Nokia Siemens Networks where the major theme of work was basically computer networking, the network management, etc. See, you can see that my B.Tech project was different and my working environment, the first working environment was different. But still, the B.Tech project, its modality of working, right? How team skills, etc., give me very good inputs and very good inputs for me to work further in the company. Now, so after completing my tenure, after completing 2 years at Nokia Siemens Networks, I had went for postgraduate studies and PhD studies, of course. Now, all these studies, when we try to, if you want to join such reputed institutes, obviously you have to go through a set of procedures like written test, interviews, etc. So one common question you can anticipate for most of the technical interviews is that, what was your B.Tech project? Right? What was your B.Tech project? What was the motivation? What is the objective? What did you achieve? So these things you will have to explain in most of the technical interviews that you will give in your life, right? So this the B.Tech projects will really pay way for your higher studies, if you're interested. Now, a sidekick of this B.Tech project is that you can get visible research output in the form of international journals, international conference, Of course, if you are developing a good product or a good solution, you can patent it, and awards and recognition, etc., will follow. Right? So please, for all the my younger minds out here, I will say that the B.Tech UG projects are quite important. I mean, they have to be done with utmost seriousness. You have to also kind of take the pain of going through this schedule, and you have to spend midnight oil, and then finish the task. When I mean finish the task, it's not like, it may not be like finishing the entire objective. You have to reach at least a meaningful, logical conclusion, right? So moving ahead now, as motivation is over, so now we see there's always a question which was there in my mind when I was in 7th semester of my B.Tech program. Many of my students also have this confusion, right? What should be the field or topic of my project? So, I mean, in my maybe 1 decade back, there was no internet. There was no, I mean, there was internet. Of course, it was not as free as now or as available as now. But it was very difficult then to kind of converge to a specific topic. Now maybe you are having better resources. You will be, it is slightly more easier to kind of finalize your project topic. But then, I think most of you, most of the students are from one of these branches, which I have given in slide number 12: electronics and communication, instrumentation, electrical and electronics, instrumentation control, biomedical, mechatronics, etc. So you see, the point is that each of these fields, each of these degrees or main topics have many number of subtopics. So I mean, each topic would have its own merits and demerits. Some of the topics would be the state of the art ones. Some of them may be classical ones. Some of them may lead to a product. Some of them may give to an some of them may act as a catalyst for future product development, etc., etc. So choosing the topic is is a very challenging part. I believe that it has to be done by the student itself. A person like me who is giving a lecture like this may not be able to suggest you the right topic. It depends upon your aptitude, attitude, right, etc. So what I would do instead is that I would try to give some guidelines, general guidelines on selection of the project topic. So these guidelines are kind of derived from my experience. They may not be universal. I mean, they may not be universal, and they can be argued upon also. But this is from my experience of doing a B.Tech project in University of Kerala 12 years back, and also of guiding about 40 final year main projects in IAST and IIT Kharagpur, and about 40 other internship projects. So usually what I see is that the topic that student chooses will be either the topic of his interest, or most of the cases it might be the topic where the latest advancements are happening. Or sometimes the student will approach the supervisor, and supervisor will already have a problem, which will be maybe which will be falling under the expertise of the supervisor. So then the topic would be pertaining to the expertise of the supervisor. So most of the cases, I would say 99% of the topics will fall under these 3 categories. Now, but still, you can consider some of these guidelines, which I'm going to tell, while you choose the topic. Right? Now, see, as you know, your B.Tech undergraduate project is a time-bound one, right? in IAST, we do, students do B.Tech projects for about 4 or 5 months, individual B.Tech projects for 4 or 5 months. In maybe when I was at Kharagpur, it was the B.Tech project was over 2 semesters. One semester was fully devoted for project, and another semester they give some efforts for the project. They had theory courses also in that one of the semesters. Now, in different universities, different practices and different time constraints are there. But when you choose the project, you should consider the feasibility of that project. That is very important. I mean, like if your project is say for 4 months, you should not aim to send a robot to Mars, right? That's quite clear. I mean, the feasibility, whether we can get a meaningful output of this project should be just thought about at least in the start, right? Then for selection of this B.Tech project, you can adapt from and you can take clues from your previous experiences. That is why I always tell that the mini projects and internship activities are quite important in a B.Tech curriculum. I mean, finally a project, yeah, it is the most important thing. I understand that, but you see, so you have to do a nice, worthwhile main project. But main project happens in the last year. But you have first 3 years. In the first 3 years, it should not be just like you are doing theory courses supplemented by lab material, supplemented by lab courses. But I feel you will get some more time to spend on some more extracurricular activities, or I should say co-curricular activities, which are related to your field of electronics and communication, or electronics or instrumentation, etc. That is why you should once maybe when you start 4th semester, when you complete 3rd semester, I believe if there are some young, I believe that you should start doing some kind of projects. It can be self projects, or you can approach a guide, or you approach a supervised professor and do some kind of activity. I mean, you have time, I feel so. So these kind of small mini projects, it need not be even official. I mean, you can do small works, small internship. You can even do internship during your summer vacations, winter vacations, if there are any, at maybe other institutes, right? So these kind of experiences are quite important, and they will help you to evolve and choose the kind of choose a good topic, a feasible topic for your undergraduate project. So another one is that if you want to choose a topic, you should do some kind of a prior art survey, or what you popularly call it as a literature survey. But here I have just one suggestion. So when different people do literature survey in different methods. So some people, some researchers or some people do a very exhaustive literature survey before they finalize the topic. Some people do not do do very minimal literature survey, and they just go on with their ideas, and they will see once they reach a point, once they reach a logical conclusion, then they will come back and do literature survey, right? A kind of post result literature survey. Yeah, both these approaches have their own merits, demerits. But because considering that you are having a time bound project for 5 months, I don't know whatever that time, I would say that you should not do an exhaustive literature survey at the start, because you will lose on valuable time. I mean, you have to do some kind of a survey, some kind of a overview, prior art search, etc. You have to do. But then that is for you to get exposed to the activities happening in the related fields of your project, right? And you can get some reference papers, etc. That is all is okay. But you should not just tell that I will do literature survey for first 1 month, then I will start with the design in the second month. I don't think that is correct. I feel that literature survey is always a continuous process which should be carried out till you submit your thesis, right? So literature survey should go on and on. I mean, parallelly you should do your design activities, your development activities, fabrication activities, etc. At each point of this time, at each point of the even flow, like design, fabrication, etc., you will have to do some kind of literature survey. So please, I would suggest you to follow such a kind of approach. Now, there is another point. I mean, how now novel or how original your topic is. Now, personally speaking, I don't think that a Btech project should be very novel one or very original one. No? But yeah, if you are able to do some incremental progress, incremental novelty, incremental originality, it would be appreciated very well, right? I mean, like even see, if you have to do a very clear novelty, or you have to showcase or demonstrate a clear novel component, it will take obviously a time which is more than 4 or 5 months. But if you can exhibit or show some kind of an technical contribution, that would be appreciated very well. Now, yeah, we are learning electronics, so we can contribute to the society, right? We can make very useful products for the society, right? We can, if you want, if you wish to go in such a direction, you can like go into, say, biomedical engineering or biomedical signal processing or automotive sector, etc. So yeah, it depends whether you want to do a socially useful solution or whether you want to do a theoretical problem, depends on the candidate or the student. But building a socially useful product has its own advantage. Now, another one is that especially in our space industry, we try to do indigenization. I mean, it is adapted to other industries also. I mean, we have to say there are many products which are licensed ones or proprietary ones, which are available at very high cost. These are made by foreign countries. So if you can make a indigenous one, indigenous design, or if we can start off at least an indigenous design, then it would be very much helpful for the society again. Now, see, we are again electronics engineers can also do very good multidisciplinary work. We can collaborate with mechanical field and do very good mechatronics project. We can collaborate with mathematics field and do something like kind of mathematically intensive electronic circuits or electronic product development. They are also very much appreciated. We can also collaborate with, say, physics field, or even say something like a computer science field. And we can do very good multidisciplinary work. Today, there is a very good ample scope and opportunity for doing multidisciplinary research. Now, a personal advice again from my side is that in Btech curriculum, in the entire span of 4 years, you should at least do one hardware project. I mean, I'm not telling this because I am kind of an applied electronics instrumentation in sensors guy. No, it's like I'm not telling that your main project should be hardware one. But what I'm telling is that in the entire for span of 4 years, you should at least have touched hardware, or you should have carried out a hardware project, because finally we are all engineers, or you are aiming to become engineers. some hardware project execution will give you a very good confidence. I mean, you can work on latest technologies like deep learning, machine learning, or component analysis methods, etc., etc. That is, all these are software-based methods. Are, I understand they are quite, quite trendy ones, and they are quite efficient ones, etc. But apart from those things, if you do one hardware project, you will get to a feel and sense of the project, and it is very important for an engineer, right? Okay. Finally, I would say that one more point. So when you choose your interest area, what I've seen is that most of the students take the suppose a student scored well in, say, control systems. In the theory course, the students will tell that they want to do the project in control systems, right? So I don't no, I don't favor that approach. Basically, the marks that you get and the project should not be related, right? You may be good at some other course or some other field as well, right? So this is also another point which I would like to convey. Now, so based on these suggestions or based on your opinions as well, you can choose one topic. That will be the initial topic, I would say, right? That is just for you to make the first baby steps. Then it's on you to evolve and modify and enhance the topic and reach and complete the UG project. So I would say the initial topic is just the starting point for you, and it is not the final thesis problem. The final thesis problem will be or need to be continually evolved during the course of the project, right? Like you maybe the case that the initial topic that you select can contribute to only one chapter. Then you will modify the design, modify the software, modify the hardware, etc., and get better refined results or better results in the next parts of the thesis. So please understand, you are just choosing the initial topic or initial objective, but you have to move forward. After you do some work, you will be able to, even you will feel that you have a better topic with you, right? So please evolve yourself as you do your B.Tech project, B.Tech project and execution. Now, next, I would like to just share my experience on what is the kind of events, what is a process flow that we commonly encounter in a project. So these can be applied to even undergraduate projects. So first, as I mentioned, we have, you might have now chosen an initial topic. See, you should be able to explain your project motivation, objective, etc., to your younger sibling, or see any other younger person, or even a third standard, fourth standard student. I mean, they should also feel that your project is worthwhile one, right? So, I mean, when I tell defining the project and motivation and objective, you should define it in such a manner that a third person or a layman can understand and appreciate your project, right? That is very important, right? If when you do so, you will see that, or when you just explain your project to an younger person, you will understand it, and you will understand that you will get better insight to your problem, because such younger minds, even younger minds, would ask some very basic questions. So this will make you again to think and refine your B.Tech project. Now, you have to have, once the motivation objective is designed, motivation objective is finalized, you'll have to kind of formulate a basic design. So some basic design, if it is you are trying to make a circuit, you have to draw the circuit, right? You have to draw the circuit, you have to ensure that the circuit performs a desired action, etc. So please understand that when I mean design methodology, you have to again iterate. You have to start with an initial design. The initial design may not be the perfect one. You have to move forward. So you have to do some associated mathematical formulations, if any. So now at this stage, you might have kind of reached some design, some circuit or some software would be available with you. Now, once this initial part is available, you can do some kind of a performance evaluation. So performance evaluation can be in the form of simulation studies. So in simulation studies, if you see, it's quite important to identify the tool, the environment in which you are doing the simulation. This can be even you can think of this tool even while you are doing kind of a feasibility studies, right? Because you should ensure that the tool is available. If tool is not available, you will not be able to do your simulation. So if maybe that is again a very important point I would like to discuss on. So these days you will get a lot of freewares, right? So try to use there are good freewares available. Try to use such good free softwares and perform your simulations. But these kind of identification, etc., you can even do in your in what you call the feasibility time frame. Now, after familiarizing the tool, you can run some kind of an initial simulations. Initial simulations are based on the initial designs. So once you do the your initial simulations, you will see that there are many gaps, there are many issues with your existing design. So you have to again go back to your design table and improve the methodology. And then again, you have to perform enhanced simulations, re-simulations, etc. So this cycle goes on. I mean, design simulation or design performance evaluation, design performance evaluation, etc. This cycle goes on. We have to continuously iterate and evolve the design, right? Like that's a very important thing. See, you have to take the pain of coming to the right design or the optimal design, right? Optimal design can be achieved only if you work no, if you just work with the help of performance evaluation studies. Now, many of the projects will have some kind of an experimentation with them. So again, you have to have some plan for experimentation. So please, this is somewhat different from the lab course or the experimentation which is associated with the lab course. Now, here you are the owner of your project, or the project or the idea is your kind of a baby. So you have to have that kind of feeling, and you have to have a very good grip on the hardware project execution. Since you have to first see that the equipments and the components are available. Like you have to first, if you are say developing a sensor, you have to make a small hardware prototype. So when you have to develop a small hardware prototype, you will have to get some kind of accessories or consumables from the external market. Then you will when you go to the market, or when you go to the electronic shops, you will get another form of learning, right? You will learn from those people also. So hardware prototype development is something which needs to be carefully done. And you, as I mentioned, you will have to interact with many people during this step, not only with the the electronics shopkeepers, but also with say mechanical engineers. In case if you are developing a mechanical hardware, you might have to you may have to discuss with a kind of a like what you call a lab assistant and many such people for this hardware prototype development. Then, of course, next step, most of you will be well accustomed with. You have to develop the circuit in a breadboard or printed circuit board. and kind of do a modular testing of the circuit alone, or the or if it is software, modular testing of the software, one part of the software. See, I was a software engineer, so see, I feel that the project flow in case of a software and hardware project are almost similar, right? So then you have to identify the bugs in your circuit or software, whatever it is. After identifying and fixing those bugs or issues, maybe if it is an electronic circuit, even you designed, you might have you might not have considered the case of shielding or guarding, right? So when you do experimentation, you will see that the 50 hertz interference or such external sources are causing a lot of problems. Then you'll have to develop proper shielding techniques into your circuit. So such kind of reiterations, design reiterations are also required when you do experimental evaluations. Now, finally, you see, whatever you will experiment and you will get some results. But the important point is that you should see that your experimental results are corroborating or matching well with your simulation results, simulation or theoretical results as well. So most of the cases, if you see, the experimental results may not exactly follow simulation result. I mean, hardware experimentation results may not exactly follow simulation results. Obvious reasons, obviously. But then you should be able to justify why they are not matching, right? You have to draw proper inferences. You have to draw proper discussions from out of your results, right? That is quite important. Just getting results will not give you will not get you appreciation. You have to draw relevant inferences. You have to discuss. You have to make proper discussions about your results achieved. Then you can say that you have done something worthwhile. So once this is finished, again, like design, reiterations, inferences will go on. Now, finally, you have to also compare your performance with the prior art, right? Suppose if you are making a product, right? Suppose if you are making something like a blood pressure monitor, you are making a blood pressure monitoring instrument. You'll have to compare the performance with the commercially available ones. So performance comparison is quite important. It will really give you confidence, right? Whether your product is above or below in performance above the prior art. If it is below, you will be able to improve because you have some experience on working on such instrument for the past few months or whatever it is. Right. So performance comparison is quite important. Finally, I mean, you have to assimilate the knowledge that you have gained in the form of a thesis. So thesis writing is quite, I should say it's a very challenging one. We have to do it very carefully and you have to put enough adequate efforts for thesis writing. So the art of writing good thesis is itself a different, it's a different vast topic. Maybe I would maybe try to give some glimpses on that in this lecture, but detailed discussion may be needed or detailed presentation may be needed on writing good B.Tech thesis. Obviously, you will have to present your result before your renowned faculty members. So in that case, like you should know how to present your research as well, or how to present your product development as well. So this thesis writing and presentation are again quite important when you consider your future endeavors. Because you see, again, I am taking my example. I did a control instrumentation project. So I naturally wrote a report and made a presentation on that particular field. But I even that report, which was in a different area, gave me kind of a like vast experience for my for the reports which I had to write in my company. So when you are working in any company or even when you are going to higher studies, you will have to write reports. People will want you to compress and consolidate the knowledge into one single document. So that will be obviously a requirement. So you should learn to write a good thesis when you complete your BTech curriculum. Obviously, you also have to present well. So the presentation skills also have to be gathered or has to be developed during this BTech project. So in case if there are any visible research output, please you should feel free to communicate to reputed places. You should not sit behind. You should take the pain. If you are done till this point, the last step is not very difficult. You have to just take the pain and maybe publish or patent your ideas, etc. And then somehow make your project kind of a socially relevant one, right? So finally, I would like to tell one more thing. So how do you define a successful project? So I mean, like it's my personal opinion what I am going to tell now. It may not be correct, but still. So I feel that a successful project is not successful project need not have a direct relationship with the grade, publication, patenting, etc. So highest grade may not guarantee a successful project. So many student projects may not have produced desired outcome or result. See, I can tell that in the 40 odd UG projects, main UG final year projects that I've guided, maybe around 15 or 16, around that number would have got kind of desired outcome. But other projects are also still valuable or excellent ones, I should say, because see, success, as you know, I was told in one movie, I believe more in excellence rather than in success. Success will automatically come. You see, if you had done a good amount of hard work, if you have perceived well, then I can tell that your project was successful or your project was valuable. If you had understood the problem statement and if you are able to explain the motivation, methodology, and results to an esteemed panel of faculty members and say our industry counterparts, and if they had appreciated your work well, then I would say your project is still valuable. If the project had given you or enhanced your knowledge levels, then you, I would say your project is valuable or an excellent one. Right? Finally, this is just a BTech project. You have to you will have to face a lot of more challenges with much more stringent deadlines in your career. So this is just a starting point. So try to make a meaningful output or out of this 4 or 5 months of project work. Then that kind of meaningful outcome will give you a great amount of confidence to move ahead. You see, when you move on to an industry, I always have a feeling that the first year at the industry is a year in which you will gather the most amount of knowledge because you will be fresh. You will be the newcomer in that company or in a higher studies environment. So if you want your first year of your career, professional career, to be very much successful, then your BTech project should be a valuable one, right? Your BTech project should have a valuable outcome. So, like I would, kind of end my generic discussions on or generic thoughts or generic guidelines which I had on BTech project execution. So now I would like to go on to some of my experiences, specific experiences which I had with my B.Tech students. So I have been guiding B.Tech students for now about 6.5 years. So about 40 undergraduate students main project and 40 odd internship students, etc. So I would like to just explain how we proceeded with the execution. Hopefully, you will get some kind of an experience. You can take some clues from this. So if I can just we can maybe stop for a small break, then we can continue for the case studies. So in case if there are any questions, queries, doubts regarding the initial part, the generic part, I am available here. We can discuss.
Thank you, sir. Now let's move on to another 10 minutes audio. So I'll just present my screen and I'll play an audio. If anyone have any doubt, you can post it in the chat box. And that you select to all panelists while you are sending the questions and queries in the chat box.
Students, you can feel free to ask any of your queries. So you can I can answer them. I would have experienced most of the issues or problems or doubts which you might have in your minds.
Good morning, sir. Sir, Deepയാണ് faculty. സാറിൻ്റെ രണ്ട് ക്ലാസ്സിൽ ഞാൻ അറ്റൻഡ് ചെയ്തിരുന്നു. സാർ എനിക്ക് ഇത് പ്രോജക്റ്റിൻ്റെ അല്ല, ഈ സ്റ്റുഡൻസിന് നമുക്ക് IST-യിൽ ഇന്റേൺഷിപ്പ് പ്രൊവൈഡ് ചെയ്യാൻ പറ്റും സാർ? സ്റ്റുഡൻസിനോ ഫാക്കൽറ്റി അങ്ങനെ ഒരു സിസ്റ്റം അവിടെ ഉണ്ടോ സാർ?
We have a system. What we do is that there is an opportunity for summer internship and winter internship. What we do is we invite applications from students who are from different parts of India. They can apply. So we maybe if it is for summer internship, the duration is from May to June, something like that. I hope I am audible, right? Audible? Hello?
Audible, sir.
Yeah. In the summer internship is usually carried out from May to July, some 2-3 months, and winter internship is on December. So the applications for summer internship are usually invited during say February around that time frame, and the winter internship applications is around August, around that time. We publish a set of topics. Faculty members publish a set of topics in one website, which is internship.ist.ac.in, something like that. It is available, and so what is different? Many students come, and based on the applications, we select a few. And depending upon their project, on our project requirements, we invite them to our college. they make presentations. So they do their work and go. I mean, they get some experience and go back. So what I feel is that many of the students who have come to me are from central universities, like NIT, IITs, etc. But of late, some students have even come from our colleges, for example, TKM College. Once girl has come and worked with me for during the last summer, 2019 summer. She had got a journal paper. So another student from this Shastra University had worked with me. Many different students from nearby colleges also have also come. They had a good resume with them. But see, one thing which I noted that is that the exams of our universities are kind of Madam, can you mute yourself?
Okay.
So the one thing I've noted is that the exams of our universities are kind of coinciding somewhat with our internship periods. Which is not the case in the central universities.
Okay, sir.
But still, we had tried to accommodate the students because we are trying to give extra time, etc.
Oh.
To meet the student demands.
In which semester they are studying? It's important.
No, usually we tell 5 semesters should be completed.
Okay, sir. Is there any provision for internship or training of faculty other than
it is there. I mean, we regularly conduct some training programs, etc. It is there. I mean, it is factor for faculty as well as industry counterparts.
Okay, sir. Thank you, sir.
Thank you, sir. So I'd like to now share. I'd like to share audio by Professor P.S. Chandramohan, sir. Sir is the publication lead or publication head of IEEE PES Kerala Chapter, as well as the former principal of GEC Barton Hill. He is the recipient of IEEE PES Outstanding Engineer Award in grade 15 years category by IEEE PES headquarters.
B.Tech പ്രോജക്റ്റുകൾ തയ്യാറാക്കുമ്പോൾ ഗവൺമെന്റ് എഞ്ചിനീയറിംഗ് കോളേജ് മുൻ പ്രിൻസിപ്പൽ ഡോക്ടർ P.S. ചന്ദ്രമോഹൻ സംസാരിക്കുന്നു. എഞ്ചിനീയറിംഗ് ഡിഗ്രിയുടെ അവസാന സെമിസ്റ്ററിൽ മിക്ക യൂണിവേഴ്സിറ്റികളും പ്രോജക്റ്റ് പഠന ഭാഗമാക്കിയിട്ടുണ്ട്. അവസാന സെമിസ്റ്ററിൽ ഇത് പൂർത്തിയാക്കിയാൽ മതിയെങ്കിലും 7ാം സെമിസ്റ്ററിൽ തന്നെ ഇതിന്റെ പണി തുടങ്ങിയിരിക്കണം. ചിലയിടങ്ങളിൽ 3ാം വർഷത്തിൽ മിനി പ്രോജക്റ്റ് ഉണ്ട്. എന്താണ് പ്രോജക്റ്റ് കൊണ്ട് ഉദ്ദേശിക്കുന്നത്? 4 വർഷം ആർജിച്ച എഞ്ചിനീയറിംഗ് പരിജ്ഞാനത്തിന്റെ ഒരംശം പ്രായോഗിക തലത്തിൽ കൊണ്ടുവരുന്നു. ഇവ നിത്യജീവിതത്തിലോ വ്യവസായ, വാണിജ്യ, വിനോദ രംഗങ്ങളിലോ പ്രയോജനപ്പെടുന്ന ഒന്നായാൽ ഏറെ ഉത്തമം. ബിടെക് പ്രോജക്റ്റുകൾ ഗവേഷണ പ്രോജക്റ്റ് പോലെ ഒറ്റയ്ക്ക് ചെയ്യുന്ന ഒന്നല്ല, 3-4 പേർ ചേർന്ന് ചെയ്യുന്ന പ്രവൃത്തിയാണ്. അത് കാരണം ഒരു ഗ്രൂപ്പിൽ ഒരുമയോടെ പ്രവർത്തിക്കാനുള്ള പരിശീലനവും ഇത് നൽകുന്നു. ഒരു അധ്യാപകന്റെ മേൽനോട്ടത്തിലാവും പ്രോജക്റ്റ് തയ്യാറാക്കുക. എങ്ങനെ ഒരു പ്രോജക്റ്റ് കണ്ടെത്താം എന്ന് നോക്കാം. 1. ജീവിതകാലം മുഴുവൻ അഭിമാനത്തോടെ പറയാൻ കഴിയുന്ന ഒന്നാണ് ഈ പ്രോജക്റ്റ്. ഡിഗ്രി കഴിഞ്ഞ് ഉടനെ നിങ്ങൾ ഒരു ജോലിക്കായി ഇന്റർവ്യൂവിനെത്തിയാൽ സ്വാഭാവികമായി ഉണ്ടായേക്കാവുന്നതാണ് എന്തായിരുന്നു നിങ്ങളുടെ പ്രോജക്റ്റ് എന്ന ചോദ്യം. അന്നേരം തീർച്ചയായും കഴിവുള്ള ഒന്ന് തന്നെ പറയാനുണ്ടാവണം. 2. മിടുക്കരായ വിദ്യാർത്ഥികൾ പുതുതായി എന്തെങ്കിലും വികസിപ്പിച്ചെടുത്തെന്ന് വരും. ചിലപ്പോൾ പാറ്റന്റ് ചെയ്യാവുന്ന കാര്യങ്ങൾ തന്നെ ഇവർ വികസിപ്പിച്ചെടുക്കാറുണ്ട്. പ്രോജക്റ്റിനെ ആധാരമാക്കിയുള്ള ടെക്നിക്കൽ പേപ്പറുകൾ ദേശീയ അന്തർദേശീയ പ്രസിദ്ധീകരണങ്ങളിലോ കോൺഫറൻസുകളിലോ അവതരിപ്പിക്കുന്നവരുമുണ്ട്. ബിടെക് പ്രോജക്റ്റുകളായി ഗവേഷണ തലത്തിലുള്ളവ ഉദ്ദേശിക്കുന്നില്ലെങ്കിലും ഗവേഷണ അംശമുള്ളവ ഉത്തമം തന്നെ. 3. പഠിച്ചെടുക്കുന്ന സാങ്കേതിക പരിജ്ഞാനം പ്രായോഗിക തലത്തിൽ എത്തിക്കാൻ കഴിയുന്നത് വിദ്യാർത്ഥികളെ സംബന്ധിച്ചിടത്തോളം ചാരിതാർത്ഥ്യജനകമാണ്. അവർക്കത് കൂടുതൽ ആത്മവിശ്വാസവും നൽകും. 4. നിലവിലുള്ള സാങ്കേതിക വിദ്യകളെ മികവുറ്റവയാക്കാൻ ഉതകുന്നവയാവാം പ്രോജക്റ്റുകൾ. ജനജീവിതവുമായി നേരിട്ട് ബന്ധപ്പെട്ട നിരവധി പ്രോജക്റ്റുകൾ കണ്ടെത്താം. അന്ധരെ സഹായിക്കുന്നവ, ഇംഗിതമനുസരിച്ച് പ്രവർത്തിക്കുന്ന വീൽ ചെയർ, വാഹന അപകടങ്ങൾ ഒഴിവാക്കാൻ സഹായിക്കുന്നവ, ഷോർട്ട് സർക്യൂട്ടുകളും വൈദ്യുത അപകടങ്ങളും മുൻകൂട്ടി പ്രവചിക്കുന്ന സംവിധാനങ്ങൾ, കെട്ടിടങ്ങളിലെ സുരക്ഷാ സംവിധാനങ്ങൾ, ഊർജ ഉപഭോഗം നിയന്ത്രിക്കുന്നവ, ഊർജ സംരക്ഷണ ഉപാധികൾ, പുതിയ ഊർജ സ്രോതസ്സുകളെ പ്രയോജനപ്പെടുത്ത്, കെട്ടിട അവശിഷ്ടങ്ങളിൽ പെട്ടവരെയും വെള്ളത്തിൽ മുങ്ങിത്താണവരെയും ഒക്കെ കണ്ടെത്താനും രക്ഷപ്പെടുത്താനുമുള്ള സംവിധാനങ്ങൾ, കെട്ടിട നിർമ്മാണത്തിന് ബലവും സുരക്ഷിതവും ഒപ്പം ചെലവ് കുറഞ്ഞതുമായ വസ്തുക്കൾ, ആയാസം കുറയ്ക്കുന്ന കാർഷിക ഉപകരണങ്ങൾ, കായികാധ്വാനം കുറയ്ക്കുന്നതും കൃത്യത ഉറപ്പുവരുത്തുന്നതുമായ പണിയായുധങ്ങൾ, വാർത്താവിനിമയ രംഗം കൂടുതൽ കാര്യക്ഷമമാക്കൽ, കേടുപാടുകൾ മുൻകൂട്ടി പ്രവചിച്ച് ഉൽപാദന നഷ്ടം ഒഴിവാക്കാൻ കഴിയുന്ന സംവിധാനങ്ങൾ, വൈദ്യുതി ഉൽപാദന പ്രേഷണ വിതരണ രംഗങ്ങളുമായി ബന്ധപ്പെട്ട നിരവധി കാര്യങ്ങൾ, കമ്പ്യൂട്ടർ നിയന്ത്രിത ഉപകരണങ്ങൾ, സമ്പത്ത് ഉൾപ്പെടെയുള്ള പ്രകൃതി സ്രോതസ്സുകളുടെ ചൂഷണം കുറയ്ക്കാനുള്ള തന്ത്രങ്ങൾ തുടങ്ങി എത്ര പ്രോജക്റ്റുകളാണ് കണ്ടെത്താൻ കഴിയുക. എന്തു തന്നെയായാലും തങ്ങൾ വികസിപ്പിച്ചെടുക്കുന്ന പ്രോജക്റ്റുകൾ സാങ്കേതിക രംഗത്ത് ഒരു മുതൽക്കൂട്ടാവുമ്പോഴത്തെ ചാരിതാർത്ഥ്യം ഒന്ന് വേറെ തന്നെയാണ്. 5. എഞ്ചിനീയറിംഗ് പഠനത്തിന് ആവശ്യം വേണ്ടുന്ന ഒന്നാണ് അന്വേഷണ ത്വര. എന്ത് കണ്ടാലും ഏത് കണ്ടാലും എന്തുകൊണ്ട് എങ്ങനെ എന്ന ചോദ്യങ്ങൾ മനസ്സിൽ ഒരു ചോദ്യം, ഇതിലും ഭംഗിയായി ഈ പ്രവൃത്തി ചെയ്യാൻ കഴിയില്ല എന്ന ചോദ്യം. അതാണ് നമ്മെ ഗവേഷണങ്ങളിലേക്കും നല്ല പ്രോജക്റ്റുകളിലേക്കുമൊക്കെ എന്നും നയിക്കുന്ന ഘടകം. 6. പാഠപുസ്തകങ്ങളിലും ക്ലാസ് മുറികളിലും മാത്രമുള്ളതാവരുത് എഞ്ചിനീയറിംഗ് പഠനം. ഇന്ന് വിജ്ഞാനത്തിന്റെ വഴികൾ നിരവധിയാണ്. ആനുകാലികങ്ങൾ, കുറെ കൂടി അഗാധത പേറുന്ന ശാസ്ത്ര സാങ്കേതിക ജേർണലുകൾ, മികവാർന്ന പുസ്തകശാല, ഇന്റർനെറ്റ് സംവിധാനങ്ങൾ ഒക്കെ പ്രയോജനപ്പെടുത്തണം. വിദഗ്ധർ നയിക്കുന്ന ചർച്ചകളിലും സെമിനാറുകളിലുമൊക്കെ കഴിയുന്നിടത്തോളം പങ്കെടുക്കുകയും വേണം. അങ്ങനെയൊക്കെയാണ് പ്രോജക്റ്റിന് ഉപകരിക്കുന്ന ആശയങ്ങൾ പലപ്പോഴും കണ്ടെത്താൻ കഴിയുക. മാത്രമല്ല, ബന്ധപ്പെട്ട രംഗങ്ങളിൽ പ്രവർത്തിക്കുന്നവരെ കണ്ടെത്താനും അവരിൽ ചിലരുമായെങ്കിലും ബന്ധം സ്ഥാപിക്കാനും ഇത്തരം വേദികളും തുടർന്നുള്ള ഇടപെടലുകളും ഉപകരിക്കും. പ്രോജക്റ്റുകൾ കണ്ടെത്താൻ മാത്രമല്ല, പ്രൊഫഷണൽ കരിയറിന്റെ വളർച്ചയ്ക്ക് ഇത് അത്യന്താപേക്ഷിതമാണ്. 7. 3-ാം വർഷമൊക്കെ ആവുമ്പോഴായിരിക്കും പഠിക്കുന്ന ബ്രാഞ്ചിനെ പറ്റി ഒരു ഏകദേശ രൂപം കിട്ടുക. അന്നേരം മുതൽ മുഖ്യ പ്രോജക്റ്റിനായി ഒരു വിഷയം കണ്ടെത്താനും ശ്രമിക്കാം. ഈ കാലഘട്ടത്തിനുള്ളിൽ ഡിപ്പാർട്ട്മെന്റിലെ അധ്യാപകരെ പറ്റിയും ആരൊക്കെ ഏത് മേഖലകളിൽ പ്രവർത്തിക്കുന്നു അല്ലെങ്കിൽ ഗവേഷണം നടത്തുന്നു എന്നതിനെ പറ്റിയും ഒരു ഏകദേശ ധാരണ ഉണ്ടായിരിക്കുമല്ലോ. അവരോട് വിഷയങ്ങൾ ചർച്ച ചെയ്യണം. മനസ്സിനിണങ്ങിയ ഒരു പ്രോജക്റ്റ് കണ്ടെത്താൻ ഇത് സഹായിക്കും. 7-ാം സെമസ്റ്ററിന്റെ തുടക്കത്തിലെങ്കിലും ചെയ്യാൻ പോകുന്ന പ്രോജക്റ്റിനെ പറ്റി വ്യക്തമായ ധാരണ ഉണ്ടാക്കിയെടുത്തിരിക്കണം. 8. ഉന്നത പഠനത്തിന് ഉദ്ദേശിക്കുന്നവർ തങ്ങൾ സ്പെഷ്യലൈസ് ചെയ്യാൻ ആഗ്രഹിക്കുന്ന മേഖലയുമായി ബന്ധപ്പെട്ട ഒരു പ്രോജക്റ്റ് കണ്ടെത്തുന്നതാവും ഉചിതം. അന്നേരം ആ മേഖലയിൽ കൂടുതൽ അറിവ് സമ്പാദിക്കാൻ പിന്നീട് ഉന്നത പഠനത്തിനായുള്ള ടെസ്റ്റിലും ഇന്റർവ്യൂവിലുമൊക്കെ നേട്ടം കൈവരിക്കാനും ഇത് ഏറെ സഹായിക്കും. 9. മിക്ക യൂണിവേഴ്സിറ്റികളും 1-2 സെമസ്റ്ററുകളിലായി 10ഓളം ക്രെഡിറ്റ് പ്രോജക്റ്റുമായി ബന്ധപ്പെട്ട് വകയിരുത്തിയിട്ടുണ്ട്. സാധാരണ വിഷയങ്ങൾക്ക് 3-4 ആണ് ക്രെഡിറ്റ് എന്ന് ഓർക്കുക. അതുകൊണ്ട് തന്നെ പ്രോജക്റ്റ് നല്ലവണ്ണം ചെയ്യാനും അവതരിപ്പിക്കാനും ആയാൽ മൊത്തം സ്കോർ നില ഉയർത്താൻ അത് ഏറെ സഹായിക്കുമെന്ന കാര്യം മറക്കരുത്. ചില ബ്രാഞ്ചുകളിൽ 3-ാം വർഷം മിനി പ്രോജക്റ്റ് ചെയ്യിക്കുന്നുമുണ്ട്. 10. മിക്കവാറും എല്ലാ സാങ്കേതിക വിദ്യാഭ്യാസ സ്ഥാപനങ്ങളിലും ഇന്ന് IEEE, ഇൻസ്റ്റിറ്റ്യൂഷൻ ഓഫ് എഞ്ചിനീയേഴ്സ് ഇന്ത്യ, ഇന്ത്യൻ സൊസൈറ്റി ഫോർ ടെക്നിക്കൽ എഡ്യൂക്കേഷൻ, കമ്പ്യൂട്ടർ സൊസൈറ്റി ഓഫ് ഇന്ത്യ തുടങ്ങിയ പ്രൊഫഷണൽ സൊസൈറ്റികളുടെ സ്റ്റുഡന്റ് ബ്രാഞ്ച് പ്രവർത്തിക്കുന്നുണ്ട്. അവയുടെ ആഭിമുഖ്യത്തിൽ പുത്തൻ സാങ്കേതിക വിദ്യകളെയും പ്രവണതകളെയും കുറിച്ചുള്ള ചർച്ചാ ക്ലാസുകളും സെമിനാറുകളും ഒക്കെ സംഘടിപ്പിക്കുക. ഇവ പുതിയ ആശയങ്ങൾക്കും പ്രോജക്റ്റുകൾക്കും വഴി തുറക്കും. 11. പ്രോജക്റ്റുകൾ ചെയ്തുകൊണ്ടിരിക്കുന്ന സീനിയർ വിദ്യാർത്ഥികളുടെ പ്രസന്റേഷൻസ് ജൂനിയർ വിദ്യാർത്ഥികൾക്ക് പ്രോജക്റ്റുകൾ കണ്ടെത്താൻ സഹായിക്കും. ചില പ്രോജക്റ്റുകളെങ്കിലും തുടർന്ന് പലതും ചെയ്യാൻ സാധ്യതയുള്ളവയുമായിരിക്കും. 12. മുതിർന്ന വിദ്യാർത്ഥികളെ കൂടാതെ പല സാങ്കേതിക രംഗത്തും പ്രവർത്തിക്കുന്ന പൂർവ്വ വിദ്യാർത്ഥി ക്ലാസുകൾ നയിക്കാൻ ക്ഷണിക്കാവുന്നതാണ്. അവരിൽ പലർക്കും തങ്ങൾ പ്രവൃത്തിയെടുക്കുന്ന സ്ഥാപനങ്ങളിൽ പ്രോജക്റ്റുകൾ ചെയ്യാൻ സൗകര്യം ഏർപ്പെടുത്താനും കഴിയും. 13. ഇന്റർനെറ്റ് വഴി ചെറു ഗ്രൂപ്പുകൾ ഉണ്ടാക്കി അതിൽ സീനിയർ അധ്യാപകരെ കൂടി ഉൾപ്പെടുത്തി ആശയം പങ്കുവയ്ക്കലും ചർച്ചയും ഒക്കെ ആവാം. ഇത് നല്ല പ്രോജക്റ്റുകളിലേക്ക് വഴി വയ്ക്കാം. ഇതുവഴി ചിലപ്പോൾ സ്ഥാപനങ്ങൾ യോജിച്ചുള്ള ഇങ്ങനെ വലിയ പ്രോജക്റ്റുകൾ സാധ്യമാകാവുന്നതാണ്. 14. മറ്റ് ബ്രാഞ്ചുകളിലെ വ്യക്തികളുമായി ചേർന്നുള്ള ഇന്റർ ഡിസിപ്ലിനറി പ്രോജക്റ്റുകൾ പഠന മേഖലയിൽ ആഴവും പരപ്പും വർദ്ധിക്കാൻ ഉപകരിക്കും. 15. പ്രോജക്റ്റുകൾ ചെയ്യുന്നത് പോലെ തന്നെ പ്രധാനപ്പെട്ടതാണ് പ്രോജക്റ്റ് റിപ്പോർട്ട് തയ്യാറാക്കൽ. പാസ്സായി കഴിഞ്ഞ ഉടനെയുള്ള കാലങ്ങളിൽ ജോലിക്കുള്ള ഇന്റർവ്യൂവിനെത്തുമ്പോൾ ഈ റിപ്പോർട്ട് കൂടെ കരുതുന്നത് നന്നായിരിക്കും. കുറെ ചോദ്യങ്ങളെങ്കിലും നിങ്ങൾക്ക് അതുമായി ബന്ധപ്പെട്ട് കിട്ടിയെന്നിരിക്കും. പല സ്ഥാപനങ്ങളും റിപ്പോർട്ട് തയ്യാറാക്കാനായി നിശ്ചിത രീതി നിഷ്കർഷിച്ചിട്ടുണ്ടാവും. എന്നാലും ലൈബ്രറിയിൽ നിന്ന് സീനിയർ വിദ്യാർത്ഥികൾ സമർപ്പിച്ചിട്ടുള്ള നല്ല റിപ്പോർട്ടുകൾ എടുത്ത് പരിശോധിച്ച് ഇവ തയ്യാറാക്കുന്ന രീതി മനസ്സിലാക്കുക. ലളിതവും വ്യക്തവുമായ അവതരണം അവലംബിക്കുക. ആവശ്യത്തിന് ചിത്രങ്ങളും റിസൾട്ട് കാണിക്കുന്ന ഗ്രാഫുകളും ഫോട്ടോഗ്രാഫുകളും ഒക്കെ ഉൾപ്പെടുത്തി ഇന്റർവ്യൂവിനിടയിൽ അതൊന്ന് മറിച്ചു നോക്കുന്ന വിദഗ്ധർക്ക് കൂടി ഏറെക്കുറെ എന്താണ് ചെയ്തിരിക്കുന്നതെന്ന് എളുപ്പം മനസ്സിലാക്കാൻ പാകത്തിനാവണം റിപ്പോർട്ടിന്റെ അവതരണ ശൈലി. 16. ഒടുവിലായി ഒന്ന് പറഞ്ഞുകൊള്ളട്ടെ, ആരെങ്കിലും എവിടെയെങ്കിലും ചെയ്ത പ്രോജക്റ്റുകൾ ഒരിക്കലും കോപ്പി അടിക്കരുത്. സാങ്കേതിക സ്ഥാപനങ്ങളുടെ എണ്ണത്തിൽ ക്രമാതീതമായ വളർച്ച കൈവരിച്ച ഇക്കാലത്ത് ഇത്തരം പ്രവണതകൾ ചിലയിടങ്ങളിലെങ്കിലും കാണാം. എന്നും അഭിമാനിക്കാവുന്ന നിങ്ങളുടെ ബിടെക് പ്രോജക്റ്റുകൾ ജനോപകാരപ്രദവും നൂതന ആശയങ്ങൾ ഉൾക്കൊള്ളുന്നതുമായ പ്രോജക്റ്റുകൾ കണ്ടെത്താനും ഭംഗിയായി ചെയ്യാനും അതിലൂടെ നിങ്ങളുടെ സ്ഥാപനത്തിന്റെയും യശസ് ഉയർത്താനും കഴിയും.
ബിടെക് പ്രോജക്റ്റുകൾ തയ്യാറാക്കുമ്പോൾ ഗവൺമെന്റ് എഞ്ചിനീയറിംഗ് കോളേജ് മുൻ പ്രിൻസിപ്പൽ ഡോക്ടർ PS ചന്ദ്രമോഹൻ സംസാരിക്കുകയായിരുന്നു ഇതുവരെ.
It was a talk by Professor PS Chandramohan sir back in 2012. I hope it was helpful. Sir, now we have some questions in the chat box. May I read out to you?
Yeah, I think one was like, can you funding for BTech project?
Yes.
I think that is good. So I feel BTech project can be software, hardware, etc. Broad classifications. So for most of the software-based projects, you may not need any funding. You just may need a laptop and laptop and a working environment. But when you come to kind of hardware projects, you may need some kind of a infrastructure or funding. But you see, I feel that you have to start. You will always be able to start your project without any funding. That is my personal view. Like you don't have to wait for funding. What you can do is like you, with whatever facilities available in your labs or elsewhere, you can start on the project, shows, then you get some initial results, some outputs, or some inferences. Based on these inferences, outputs, etc., if you approach industries, you will get necessary funding. Not only for completing the B.Tech projects, but also maybe they also may fund you to, for to maybe start a, to initiate a startup, etc. Those kind of things also they will do. So basically, I feel that you can start off without any funding. That's my view. I mean, and one example is that, see, once I was doing, even maybe 2 years back, I was doing some low current measurement circuit, and I needed a very ultra low current op amp, ultra low current bias current operational amplifier for the project design, for the circuit design. So, but such an ultra high performance op amp would cost something like 10,000 rupees. Not about the money is one thing, and there is also a shipping delay. It will take around 4 or 5 months to get that product because it's not available in India, and there are some restrictions, etc. But then we should not wait for those 4 or 5 months, or we should not wait for that necessary money to come to us. First, what I did is that whatever the best of the op amps available in my lab, I will start up the design. When you start up the design, you will get and when you start up the design and when you do some kind of performance evaluation studies, then you will get a feel, you will get a better grip of the project. Then you will understand that you may sometimes may not need such a high quality op amp or high quality component, for instance. Right? So then in that case, you can do away with the funding requirements and you can do the projects by your own. But see, more than that, the point is that you can always start off without any special funding. Funding can come as the project get evolved. And now coming to the specific question, like, is there any funding agencies, etc.? So there are, see, I believe that many of the IEEE societies provide some kind of funding. Other option is that see, there are some this Texas Instruments challenges, analog instruments challenges, etc., analog devices challenges, etc., available. So what you can do is like you can post your project proposal to those kind of competitions, and they will give you. I mean, once if the project proposal is good enough, they will approve it, and you can like they will give you some startup kind of money for buying some components or some buying some microcontroller kits, FPGA boards, etc. But of course, once you get that components, you will have to work with them and show some kind of an visible output also to those companies or to those competitions. That is a moral responsibility. Right. So there are ample sources of funding available, but point is that you don't have to wait for that funding to come. You can start off without that also. Any other queries?
Yes, sir. There are a few more questions. So the next question is, how do we select the topics to start to do small projects?
When you tell small projects, I believe that it is kind of an unofficial projects which do not carry any credit, grades, etc. So they should be started maybe within 3 or 4 by fourth semester or so. So best way to do that is to approach a supervisor, a faculty member, and he or she will give you some ideas on the topic where of her or his experience or expertise. Then you can do some work on that, anyway, whatever you are doing, you will get some experience, right? And if you interact with the guide itself, you will get some more knowledge. And now that is one way. Another way, what we do is that we can interact with the seniors. So we can see the project reports or the presentations, if possible, of your seniors. That based on that also you can get some ideas. And nowadays, you see, I mean, you have a lot of online resources available. I mean, to just this search in online itself, you will get hundreds of interesting projects. But the question is narrowing down to one. But that narrowing down to one can be done based on the facilities which are available in your lab or in your institute. Right? So I believe that you can do small projects based on this information. Thank you.
Thank you, sir. So the next question is, so can you suggest some good project fields for the second year ECE student? I don't know what kind of projects are expected from a second year student. Also, can you provide any means to contact you after this regarding the project?
Okay, my mail address is available in my website. If you can go to IAST, or even the starting page of this presentation, my mail address is given. So I can share that to the coordinator of this program. So you can get the information. So the second year ECE programs, I mean, you see, initially I feel that, if I'm not wrong, when I studied Kerala, University of Kerala, that 1 decade back, or rather 1.5 decade back, so we had subjects like electronic circuits, solid state devices, network analysis, etc. in the third semester. Those were the starting subjects. Now the names might have changed, but the concepts more or less remain the same. So see, as a starting point, if you want to be if you are very interested, like you can always do the you can do those circuits, or you can do. I mean, you can evaluate those circuits either by in a simulation environment or in a practical environment. So this is not for any grades or something like that. This is just for your personal satisfaction, knowledge base widening, etc. So because many of the circuits or many of the concepts that you learn in your theory course cannot be fully supplemented in the lab course, because as you know, lab can be maybe 6 or 7 or 8 experiments in a typical Btech lab. But you may have other circuits or other concepts also available. You have to practice them. I mean, once you practice them, your ideas you will get much more understanding. So you can start off with that incremental step. Just you start off with understanding the concepts well. Then, by just following some of the online resources, or some online resources on small projects, etc., you can move forward. Meaning, what we used to do that, meaning those times, was that time this robotics was the kind of the field. Now it might have changed. So there used to be a lot of robotic competitions held in and around Kerala. So what we used to even in fourth semester, fifth semester, etc. We used to at least try and make some robot which can burn out the flame of a candle, something like that, and all we used to make. I mean, this is not for any credit. This is just for getting some kind of a learning. So I mean, project topics maybe there are competitions which prescribe the project objective. Then you have to make a solution which meets the project that objective. So that is also another way. I mean, there are many ways of getting into a project. Like there are many specific ways. We can discuss it offline also. If you need it, you can contact me for any further information.
Okay, thank you, sir. So the final question what we have in the chat box is, I think hardware projects needs to present through simulations and emulators. Can you explain about that and the best application softwares?
Yeah, hardware project. Okay, you need to have a simulation environment even for a hardware project. As you mentioned, as a question, the question just mentioned, we should do some kind of an emulation studies also. And then you have to go to experimentation. So, see, simulation, if it is a circuit simulation, for instance, you have a lot of freewares available, like LT Spice, Multisim, Tina, etc. are available. If you are talking about finite element simulations, I mean, if you are planning to make any electromagnetics modules, etc., you can. There are tools like ANSYS. There are comms all available. I mean, these are not the only ones. These are there are better. Like I don't know. I'm not here to compare the softwares, but I'm just telling the softwares which I am used. So, like even if it is a plotting. Yeah, right. If you have to plot the result, there are again n number of tools available. If it is to make a draw a circuit, again there are number of tools available. So these things are available. Many, I mean, for any job, you will have multitude of tools available. But see, like that selection of the tool is like more on the more a question of availability and freeware thing. Because if it is freeware, there is no problem. But some of these tools are licensed ones. Then, you have to see how to use the student versions and all. Yeah, fine.
Okay, thank you, sir. I think I think he has added something like these COVID-19 situations give restrictions to hardware availability. So he's telling like the software simulation is being used widely for compensating those limitations.
Yeah, I mean, see, hardware, it depends on what is the project that we are doing. I mean, that is what feasibility studies we have to do. I mean, suppose I believe that any undergraduate program will have an associated lab which are having a large number of electronic components, electronic equipments, etc. So, which means that you will be able to evaluate the circuit even through hardware or even through experimentation. See, for instance, like I can tell from my B.Tech project experience, I was doing an intelligent robotic gripper, a robot which grips or grabs a object with the right amount of force, optimal amount of force. So when we did, as you told, we had did some simulation studies. We were not kind of very much satisfied with that. Then see, we felt that we did to have to show something in hardware also. Then we took the pain. If you take the pain, you can realize the hardware also. Then with some amount of small funding from ourselves, self funding, we went and sat with the kind of a local hardware manufacturer. We selected the sheets, we selected the robotic arm, we designed the arm with his help, AutoCAD modeling. So everything we did by ourselves. I mean, the only thing is that we had to spend a little bit of extra effort, and then we were able to realize a miniature or a mini model of the hardware with the like with some kind of a self funding. It is not very much, so we were able to manage. So I mean, I don't think that college or the institute needs to provide everything. We can also, I mean, with minimal fundings or a minimal self funding, minimal, I mean too minimal, I mean telling you. So we will be able to make some kind of a mini or a very coarse experimental setup, using which you can do some kind of an experiment evaluation. This kind of an initial experiment evaluation will give you a very good amount of confidence, right? Because you yourself have developed the hardware and you are showing the results of your scheme, experimental results of your scheme. So it is possible, I believe. Okay. So, the questions?
Thank you, sir. Okay, sir. Is connecting space technology, electronics, and AI good for projects?
Can you just repeat? Sorry, I couldn't hear that. Hello?
Okay. Yeah, the question is connecting space technology, electronics, and AI, artificial intelligence, good for projects?
It is good. Yeah, it is good. But see, space technology, I mean, you see, if you are considering the electronics in space technology, see, it's not like some, we in space technology also, as per my knowledge, the concepts which are used to develop electronics remain similar as in other industries, right? I mean, if you are using a non-inverting amplifier, for instance, for automotive sector, you will use the same non-inverting amplifier circuit for the space industry also. Only thing is that the quality of the components will change, right? In space industry, you will have to go for maybe higher temperature rated components which can withstand from minus 55 to 125 degree. In automotive sector, you have more relaxed temperature conditions, radiation conditions, etc. So I mean, like for, I mean, space technology, the fundamentals of the electronics for all the sectors are almost the same. It's only how you, kind of um, manipulate the components or select the components for the given sector. So answer to the question, specific answer is that it's a good area. You can combine it. But see, when you tell space technology, electronics, and artificial intelligence, see, these are three different areas. I mean, I believe that in a B.Tech project, you should have some kind of a specific goal also. If you try to attend three different areas, you may not reach a perfect answer within that time bound duration. So what I believe is that if you want to apply artificial intelligence to space technology, you find out a problem where artificial intelligence is important, then work on that problem, right? I mean, so like that, or if you want to work for electronics for space technology, it's better, you can kind of develop a instrument, for instance, for measuring some parameter in space. So like, you should have a specific problem in case when you are combining those areas.
Okay, thank you, sir. So I would like to request you to continue the presentation on the how to execute successful B.Tech ECE.
Yeah, so I feel I am my slides are visible again. So
Yes, sir.
yeah, so let me give some case studies. In fact, I had prepared 3 case studies. I am not sure whether I will be able to complete all 3, but still, let me start off with my initial case study. Yeah, so this case study, sorry, one second. Yeah, this case study is kind of related to my first UG guidance experience. So this happened somewhere in 2014, if I'm not wrong, when I was faculty of IIT Kharagpur. So one student approached me saying that he wanted to do some project, right? As was the case as was the usual case, he was telling he wanted to do a project. I asked what is his interest area. So he told he didn't have any specific interest, but he likes coding. That is what he told me. But like, I am not specifically into coding, although I worked as a network management engineer for 2 years before doing PhD. But then I told them that you may approach other people who are experts in coding, or who do purely software work. But he was telling it's okay. I mean, he is also interested to do other projects also. Then I just I was in my PhD. I worked on magnetic sensors and some linearization electronic circuits. So I wanted to do something fresh because this was my first project, first student. So then I just suggested, can't you can you are you interested to work on biomedical electronics? So when I told this, he suddenly his eyes. I saw a very high interest in his eyes, and he suddenly told yes, he is interested. So then I just asked, then all, but even then this his statement of coding, he's interested in coding was with me always. So then I told him, okay, if you are interested, you can start working on biomedical electronics, and if we will try to incorporate some kind of a coding later as a project proceeds. So then we started our association. So this association lasted again for about 6-7 months, around 7 months, I should say. So the project was basically aimed at developing a non-contact capacitive electrocardiograph. So if you see when you go to hospitals or in clinics, they take electrocardiogram on you, ECG as commonly abbreviated as. So this is a very valuable signal from which you can get very useful information about heart rate, respiration rate, and many other body parameters. But as you know, if you had taken ever an ECG on you, the doctors or the nurses will first put a gel on 3 places of your body, 3 or 4 places, depends. And then they put some electrodes on top of it, and those electrodes will be connected to an electronic instrument. And the electronic instrument will give you some parameters will be displayed there. But if you see, this approach has a significant demerit in the sense that you need to put a gel and you need to use multiple electrodes, etc. So that kind of a conventional approach is not suitable for making portable equipments, because you see gel will evaporate with time. So we need to make a kind of a better solution to extract ECG waveforms from which we can estimate vital parameters. So this kind of an approach would be useful, for instance, detecting the drowsiness of an automotive driver, or health of a in-home patient, elderly patient, or like an athlete, etc. So this was kind of a small motivation which I gave him. So then what he did is that he went and studied some of the existing techniques of, say, heart rate measurement. Heart rate is the most basic signal. So we try to stick on to heart rate. I mean, that here is where specificity comes in. So if you just tell biomedical electronics or biomedical signal processing, it has n number of areas. So instead of that, we try to focus on a most basic parameter, that is the heart rate. Right? How to measure heart rate? What are the different techniques available? So that student did a extensive literature survey, and he found out the different techniques which are used to compute, which can be used to estimate heart rate, like PPG, ECG, PCG, etc. So, I mean, I'm not going to the technical details because this presentation is not finally into explaining the work. It's more like how did we execute the work. So then he found out, or we found out that there was 2 types of ECG: contact-based ECG, which is commonly used in hospitals, and there is another something like a non-contact ECG, where some kind of a research was going on in that time frame. So this non-contact ECG gave non-intrusive measurement, of course, and it can be accommodated with different parts of human body. So then what we did is that we tried to see whether what are the advantages of this non-contact. Okay, before that, we also just a diagrammatic representation of the different heart rate measuring techniques. So this kind of a study on slide number 23 helped us to see clearly explain the motivation of our research or our project. So you can see the pulse oximeter is there, but on the left hand side, pulse oximeter is a very compact equipment which is commonly used, but it requires a direct optical contact because it uses a LED and a photo detector pair. So if in case if you are wearing gloves or if you are wearing some shirt, etc., we cannot use this kind of an optical technique. Then there are phonocardiograms which based on the sound which are used, sound given by the sound given by the heart. But again, heavy signal processing is needed. So this figure on the right side represents the common ECG technique which is used in the hospitals, 12-lead ECG machine. But then what we did is that we tried to go for a non-contact ECG like this. So from which we can estimate parameters even when we are sitting on a chair or even when we are sitting on a seat of an automotive, etc. So now here next he had studied clearly what are the advantages of non-contact ECG over contact-based ECG. So you can we don't need any gel, we don't need any large number of contact leads, and the equipment can be somewhat miniaturized because we know some kind of electronics, so we know how to miniaturize the electronics also, and we can make it in such a manner that the non-contact ECG stage can be more suitable, can be suited for elderly people, infants, etc. So those advantages really motivated us to kind of work on this area. As I mentioned, this kind of non-contact ECG has a number of other allied applications like fatigue detection of automotive drivers. I think in the break, one experienced professor had mentioned this topic also, how to prevent accidents. So we had done almost exactly the same using a very simple technique. I will just try to illustrate that. So how to use ECG signals or ECG-based electrodes to detect the fatigue or drowsiness of the driver and like maybe alert him if he is sleepy. So this non-contact electrode system is also suitable for athlete or fitness monitoring of war personnel, etc. So then we are now you can clearly see that motivation, objective, etc. is defined. We have a number of we have a good motivation now. Now we went for the design, the initial design. Okay, see, you should see that this whatever design I have shown in slide number 26 is kind of a refined design. This has been obtained by a number of design reiterations. Okay, so let me, for the time being, let me show the final design that we have achieved. We use just 3 electrodes. The electrodes are designated as E1, E2, and E3. These electrodes are these electrodes are actually placed on the human body, or rather the human body or hand or something is placed on these electrodes. And these signals from these electrodes are processed by an instrumentation amplifier, INA, and further filtered, and then is fed to an digital unit, which performs a kind of a heart rate computation algorithm. So, okay, here comes the next thing. So the design is almost freezed, or at least we have made a good quality design. But then now, what should be the next component that we should focus? Usually in a typical flow, what we do is that we'll focus on the electronics, we'll do its simulation, we'll make the algorithms, we'll make the make it compact, and we'll run it in a real-time software, real-time environment, and test the circuit and algorithm together. And we'll first establish the the performance of this electronics plus algorithm. But here, then we'll test with the sensors. That is the usual follow that we follow for most of the projects. But here, we made a small exception for that general convention, because from my experience, or from our experience, I should say that here one of the most important thing is the electrodes, right? electrodes should be there. Without electrodes, and none of the electronics will work. Right? So then we first try to investigate a little bit on the electrodes itself, right? The feasibility, right? Electrodes, how can we obtain it, etc. We try to study, right? So this raw signals conditioning stage is what we try to focus initially, just to get some idea. Then we proceeded to signal conditioning, and then finally the heart rate estimation algorithm. So now coming to the signal acquisition stage, which is the electrode, again, we could have, there was no funding available. If, as one of you asked, this is strictly self-funded project. There is no funding available. So what we did is that, okay, we cannot, body electrodes can be made from different type of materials. The best recommended one is silver based electrodes or gold based electrodes, which have very good conductivity. But then we cannot go, given the limited funding available, because it's just a UG project, like first UG project for that matter. So what we did is that we took some copper. We went outside the Kharagpur market and we got some copper sheets, right? And we, with the help of the mechanical workshop, etc., we just cut it into small circular and some shapes of which are adequate for application. So we will be placing our hand on these kind of sheets. Then we'll try to acquire the signal. So this some kind of a feasibility implementation we had done at the start of this project itself, because this project is slightly special type. We wanted to show some results, right? If you didn't show the ECG signal, this project would not have been meaningful, right? We have to demonstrate the ECG signal. So we took the pain initially, and we may try to make some kind of an electrode which can be used. Now, next problem was we have to solder a wire, and you have to take output from this kind of electrodes. Then there is another problem here. When you take a wire, like solder a wire and take the signal, the signal can get affected by the surrounding interferences. Because see, you are not taking the signal from a voltage source, but you are taking the signal from your body. Body signals are quite feeble, weak signals, so they can get corrupted by the external environments. So we have to have some kind of a special shielding over here on the electrodes, so that we can acquire proper signals. So shielding also we had, or rather the student had a little bit studied and made some kind of a shielding arrangement. So the sensor part was over. Not over, it was somewhat kind of like at least something we are having in our hand. Now we have to make we have to process a signal from the sensor. So there are first two electrodes, E1 and E2, are active ones. Basically, we need to take the difference between E1 and E2. That's a standard method. To take the difference between two electrodes or two signals, we have to obviously go for a differencing amplifier. So as you know, instrumentation amplifier is the more efficient way, or instrumentation amplifier provides a more efficient way to take the difference between two signals. So we used an instrumentation amplifier with some kind of a backup protection in the form of diodes. And the last electrode, the third electrode, by convention, it is connected to the ground. So this output of the instrumentation amplifier, we know that it will be corrupted by noise, right? Because these experiments are conducted in an environment where power supply lines are also running. Power supply lines are used to excite the old CROs, oscilloscopes, power supplies, and other equipments, which may be even present in an hospital. So we developed adequate filter to remove that power line interferences. And see, we had already defined our objective. The objective is to first acquire the electrocardiogram, and then to estimate heart rate from it. So heart rate, as you know, if you have heart rate of a common typical human being can lie between say 60 beats per minute to 120 beats per minute. So, this corresponds to a frequency of 1 hertz to 2 hertz. So then we had also put a high pass filter whose cutoff frequency is something like less than 1 hertz, 0.5 hertz or so that we can nullify off the artifacts, the motion artifacts or respiration rate components, which commonly appear along with the ECG signals. Then lastly, we had a kind of an algorithm to process the this kind of ECG signals and get the heart rate. So I should say, although I'm presenting this everything in one slide, I should say we develop this till this we try to develop the circuit initially, right? After developing the sensor, we try to develop the circuit initially and try to get the VECG output. Once we get the output, we can get estimate heart rate with using one algorithm or the other. So so we had done some kind of a simulation studies also for the circuits. As I mentioned, simulation studies are important. So okay, slides are there. We try to see whether the low pass filter behavior is there. So low pass filter around 24 hertz means that 50 hertz interference will get attenuated. High pass filter also was used to get a band pass characteristic, so that we only pass signals from 1 hertz to 2 hertz, something like that. So the entire circuit was simulated. So what we did is that we simulated the circuit in a common tool, LT Spice, Linear Technology Spice. And what we got, we searched some database, biomedical database, and we got a typical biomedical ECG signal. That is a raw ECG signal, as shown here, the black colored one. This is a really noisy one. Then we fed that kind of, we imported that signal to LT Spice, the Spice software. And after this series of circuits, we see that we are able to get a very clear ECG, right? So this study shows the efficacy or the efficiency of the kind of the signal conditioning electronics. So please understand, we are doing module by module, right? Now, so you can see that this, whatever highlighted within this this box represents the clean ECG signal, which is obtained after signal conditioning. Now, we try to make a breadboarded model. You can see there's a breadboarded model over here. These are common equipments which are available in any of our labs. Breadboards are available. The components more or less will be available as well. Then we told one volunteer to place 2 hands on 2 active electrodes and the right leg on the ground electrode. And you see the setup used is, quite, you can see the setup, the old chairs, everything is old, but no, it's like we try to demonstrate output even using such environments. See, this was a starting project, so we didn't have any fund. IIT Kharagpur has a lot of funds, that is different matter. We use those funds also in the later stages, but to start off with, we have to show some results, some initial results. That is what we showed over here. Then we can get funding. So when we tested these electrodes, when we tested a volunteer on this by placing the hand on the electrodes, the output of the circuit was again a clean ECG signal, as you can see. P, Q, R, S, T, peaks can be observed in this oscilloscope. So see here, please understand the kind of merits. We have not placed any, we have not used any gel, right? We have not even placed the electrodes on the heart, right? Or near the heart rather. We have just placed our hand on legs on the copper plates, some low cost copper plates, and we had some kind of an electronics. We can develop the electronics that we know, and we got good quality electrocardiograph signals. So this electrocardiograph signals was commonly known as non-contact. There is non-contact or non-intrusive measurement. So this scheme even worked well even if there is a small layer of cloth between the electrode and the human body. like we may have to place the electrodes on the top of our shirt or top of the blouse, etc. So in those cases also the scheme should work preferably. So we tested the scheme for different cloth thicknesses, right? So I mean, so we tested with 0.26 millimeter, 0.52 millimeter. I mean, you know what? There is no infrastructure needed here. We needed some piece of cloth or some infrastructure, some thickness, and a vernier caliper, of course, to measure the thickness. Right? And we had our entire electronics and sensors with us. So when as the cloth thickness increases, you can see some noise components here, right? Noise components. This is because then I told the student, undergraduate student, oh, why you are getting this noise? I just asked him. Then he told me initially he didn't have any ready-made answer. But with our forthcoming discussions, we came to know that it is due to the common mode, increased common mode contribution of the power line noise. So basically, these were the inferences which we, the UG student, and kind of with some support from myself, were able to derive. Right? These are good results. I mean, you can see that even when the cloth thickness is around 1.5 mm, we are able to get good quality ECG signal. We can easily distinguish the peaks. Okay, this scheme also worked for different volunteers. You can see volunteer A, 25 years, another one 22 years, etc. You can see age band is around 20 because we might have taken results with most of our most of his classmates, etc. Although we saw that it was working even for aged people like lab assistants who are available over there. Now, okay, we got the signal. The non-contact electrocardiogram or the dry electrode electrocardiogram was successfully demonstrated experimentally. Simulation was already, like results were shown. So this was kind of one end of one module of this project. Now, the thing is that okay, again, what he told was there in my mind. He wanted to do coding. So then there was different ways to proceed from this point. So we could have gone on to and make better sensor arrangements, which for different applications, etc. Then, then I thought, like it is as he is interested in coding, maybe due to various reasons, maybe higher studies or some specific need, whatever it is. I told him whether he can ask him whether he can develop a very good algorithm which can detect, which can estimate heart rate from these signals. So there are many algorithms. If you just take an FFT of this, you will get a coarse estimate of the this ECG signal. But whether can you get a more reliable, accurate estimation of the heart rate from these signals? So naturally he was again more interested because he wanted to work on some kind of coding. So then he developed an algorithm. This algorithm almost was known as some Fourier interpolation algorithm. So this was almost entirely developed by himself only, because he was kind of owning the responsibility, right? He got this much good output, right? Which means that he was ready to like take it up further, and he really spent some quality effort or quantity effort in terms of quantity also, and developed an algorithm within a short span of time. Here again, he had done again in this stage also he had to do some kind of literature survey to find out the existing algorithms and see which is the best and what are the improvements he has to make, etc. So the details of the algorithm I'm not discussing, but he made a nice little algorithm, and from this it's basically kind of Fourier, basic technique is Fourier interpolation, but we do an iterative search so that we can estimate the correct peak. So finally, you can see the result. The entire algorithm was tested with the help with the electronics as well as with the sensor, and you can see the results obtained. You can see here we have tested on about some around 20 volunteers. So volunteers A to T, age 20 age is given in bracket 20, 47, etc. age. And you can see the results obtained from the results measured from the developed scheme is shown in this light green color. So volunteer A, the measured heart rate is 75. Then, as I mentioned in my initial slide, we should also compare with the prior art, right, or the existing equipment. So we got a simple pulse oximeter, which costs something like 600 Indian rupees. We got it, but as you know, the pulse oximeter is an optical device which needs a direct optical contact. But so that has a different set of disadvantages, but still we use it as a reference just to validate our measurements. So when we validated, the results were quite good. You can see the heart rate measured by the reference heart rate instrument pulse oximeter is shown in dark green color. So you can see that most cases, or all of the cases rather, the measured heart rate is following the reference heart rate. Right? Two horizontal vertical bars are close to each other, and the accuracy of the entire instrument was less than 2 beats per minute, which is quite acceptable. So, here the student did this much work, and I think he was satisfied. And I should say, as I mentioned, he took the ownership, he took the responsibility very highly in the later stages of the program. And he actually published a conference article based on this work at the annual biomedical conference held at Italy. And he himself was so interested that he went and present. He told, I wanted to go and present, he told me. And I told, then you go, then go. Then he himself went and presented at that reputed conference and got very good appreciation. So this was the first project which I have done in my career with a B.Tech student. So then that time I was so this was an official main project, final year project, if you see. Then you see, I will share one more experience. And then I was teaching some 4th semester course that around the same time, some course on instrumentation I was teaching. Then 2 students of that course approached me. It was towards the end of this first student's main project. So they came and asked me, they want to do some projects. So I again asked, what is their interest area? So one person told algorithm, one person told electronics. So I mean, so that group itself had a conflict, nice conflict, of course. Then I asked them, can you? I had a problem also. No, what I told, can you? We have shown demo. I told them we have demonstrated non-contact ECG this work. We have got some results, but I want to further improve the work and make it adapted to different applications. So that work involves, of course, algorithm development and, of course, a good amount of electronics development as well. So when I told again biomedical electronics plus signal processing, then they both of them again told yes, and they kind of reproduce this work and moved forward this work. So so please understand that now I have the 2 people who were working with me were 4th semester students, unofficial projects. There were no credits, right? But they just wanted to learn, right? So that kind of attitude is very, very good. I mean, it's very, it's very acceptable, very acknowledgeable, etc. So what we did is that we tried to extend the same principle for automotive driver. We try to kind of, we initially bought a steering wheel, demo steering wheel. I think you might know that like for this PlayStations and all, we have a demo wheel. That time, I think we bought it from some online web store. And very low cost one. I mean, I didn't want to invest on a car, or I didn't want to borrow a car, etc. So I just just started off with a demo wheel. And we integrated the electrodes on this demo wheel. So you can see two electrodes, ES1 and ES2, are the active electrodes. They are placed on the steering wheel. And grounding, so you can see that our hands will be placed one on the, let me show, I'm just starting the video. So one hand will be on the left, on ES2, the left electrode, and one hand will be in the right electrode, and we will be driving like this. So, but then in the previous scheme, we needed an electrode on the leg also. Now, I didn't want to, or we didn't want to place any electrodes on the brake, etc., or clutch, or whatever, accelerator, etc., though, because they are very critical of positions. So what we did is that we tried to investigate, and we, through using a proper literature survey, we found out that you can get ECG signals even if you place the electrodes, the ground electrodes, close enough to the active electrodes. This was proven. And then now we can place all the electrodes are placed in a single steering wheel, and the connections, outputs of these electrodes are taken to the electronics, which can be suitably accommodated within the rim of the wheel. So now we have to just place the electrodes, we have to place our hands on the electrodes on the steering wheel, and the electrodes will acquire the signal and will give it to the processing circuitry, which consists of an analog circuit, heart rate estimator, and of course you can display it if needed. So this was a very simple solution, if you see, and it can be readily integrated, right, within any steering wheel. And additional advantage is that there is no optical contact required, and this special kind of grounding configuration gives us a very low noise. So this again, it was an internship work. Then we try to follow a similar circuit architecture. There was an instrumentation amplifier. There were some kind of filters available, and this output of this analog circuit was fed to the heart rate monitoring algorithm. So you see, some of these parts, filters, etc., instrumentation amplifier, were kind of borrowed from the initial thesis itself. But of course, we improved the architecture. You can see some kind of an integrator is placed near the instrumentation amplifier, that is for kind of giving baseline stabilization. So we continually evolved and improved the architecture also. So that's a very important point, right? Now, okay, we had a small algorithm, a different simplistic algorithm, which can be even implemented within a kind of a device like Arduino or STM Discovery card, etc. Simple microcontroller kits. Now, coming to the experimentation. So you see the demo wheel which we have bought. You can see the electrodes. Electrodes are basically copper foils. Again, there is no funding. There is minimal funding needed for this. So that is why I mean, funding comes later. First, you have to show something, right? Then you can see myself, okay, on testing on the device. The electronics is made to a PCB form. You can see the LCD display. And on the DSO, you can see the ECG waveforms, right? So this is basically something like ECG on a steering wheel. So we had used simple components. I mean, okay, components, the cost of this components, even if you per piece cost is less than Indian rupees, something like 1,000. On a bulk level, the cost will further come down. All right. So then let us show the results. So this is my ECG. If you see, I mean, you can see P, Q, R, S, T peaks, right? And see, you can see that SNR is, the noise level is very small, minus 43 dB is the noise level. So this is a very good results. And even when cloth is there, I mean, there is even if there is some kind of a covering on top of this electrode, which can be present in an automotive wheel for just to increase the increase the easiness for the driver. Some kind of a wheel clothing or some kind of a covering is there, then also it is not a problem, because we are still getting a ECG signal even when 2 mm thickness cloth is present. Of course, SNR of the signal will decrease with increase in flow thickness. But see, these are very good results. I mean, ECG on a steering wheel. One of the first times anyone demonstrated ECG on a steering wheel. This was done using with the help of fourth and fifth semester undergraduate students. Unofficial work. That's more important. They didn't have any credits. They didn't get any academic credits. All they got was just knowledge, and they were ready to spend the kind of midnight in the lab or midnight oil in the lab, and they work really hard. So they had the attitude, and they kind of perceived. I mean, these results are not just obtained overnight. They kind of worked and worked and worked till these results are achieved. I mean, we face a lot of bottlenecks, right? Lot of bottlenecks when before we got these results. It's not. I mean, I don't want to explain those bottlenecks because they are specific to one project. So bottlenecks were in terms of technical issues. Bottlenecks were in terms of, say, administrative issues. Bottlenecks were there in terms of component procurement issues, right? Of course, more importantly, time issues. They had to write their quizzes. I have to teach. I have to teach, and we have to find out a common time for discussions, etc. Therefore, we are facing a lot of challenges, but still, when it came through well. Finally, we got a nice ECC signal, and you can see we have again compared the performance of the scheme with the reference schemes. You can see that the developed scheme is giving a heart rate which is very close to the reference schemes, right? The worst case error in heart rate estimation is less than 2 beats per minute, right? Now, as I was mentioning, students were further interested to do additional work. So then what we did is that we tried to see whether the scheme can be used for detecting the fatigue of your automotive driver. So we requested a volunteer to take a short nap while keeping the hand on the wheel. And we programmed our real-time embedded system to monitor the heart rate continuously. Then we saw that when the driver, or when the volunteer goes to sleep mode, or rather a short nap, the heart rate decreased. Okay, so this heart rate variability could be used to even detect the driver fatigue, driver drowsiness, and alert the driver. So this is a very useful result as far as a social perspective is concerned, right? So then see now, I think the students have reached completed one semester, one and a half semester. So they were kind of moving into the summer vacations. So then we try to extend the scheme. So we had got a conference, very good conference paper at a reputed control measurement instrumentation conference held at Calcutta from this work. Then we were further seeing what are the demerits of this work. Then we see that we are telling all these things, but you see, as an automotive driver, we know that I cannot always place my hands on the steering wheel, right? I may need my left hand to shift the gears or many other purposes. So in those cases, we may not get an accurate indication of the heart rate, right? So whenever there is a loss of contact of the electrodes with the human hand, there is a loss of signal. So then what we did is that I just posed this problem to the students, and I just asked them, can you integrate multiple sensors, right? Even if one sensor fails, can you get the information from another one? So then we thought for suitable locations, and in fact we came with a very new kind of novel architecture where we integrated electrodes on the seat belt. Right nowadays, you know that we have to wear seat belt. It's almost mandatory. It's mandatory, and almost 99% of us will do that. So seat belt is close to the human heart. So we integrated the electrodes on the seat belt and some on the seat also. And what happens is that we'll get more or we'll get better signals in this case because seatbelt is closer to the heart, which is the heart is the source of the signal. So then we had 4 or 5 combinations here, E1, E2, E3, E4, because see, we are using these kind of multiple electrodes because what we'll do is like we'll choose the best signal, we'll process the best signal from these electrodes, because for a taller person, the best signal will be coming from the electrode E1. Maybe for a shorter person, the best signal may be coming from E3, etc. So it depends upon the size and like of the person and stature of the person. So we had a kind of more reliable architecture over here where electrodes are placed on the seat belt and seat. And we had a multiplexed architecture. Analog circuit remains almost the same except for this multiplexer. And the digital processor was not only performing heart rate computations, but also it was helping to choose the right electrode or the best electrode from the given combination of 4 or 5 electrodes. So best electrode was chosen based on the concept of signal to noise ratio. Now, again, we actually got a heart rate parameter display out here, you see, and that was kind of, for me, it was a good result actually, right? Because it is a very socially relevant one, right? It can cater to the demands of the society. It meets the specifications because we are using the unused portions only, right? We can work well, it can work well even if there is a layer of cloth between the human body and the electrodes, etc. So very attractive scheme. So this would have completed the proof of concept for me, this much stage until the LCD display. Meaning I have shown we had shown the display. But there is where I felt that our B.Tech students are more smarter than maybe a little more matured ones like me. They were telling, sir, anyway, we have got the signal. So why can't we transmit it also, right? If any driver has a problem, we will not just give an audio alarm. What we can do is like we can transmit the information to a central station and let this central station take an action. So what we did is that we bought a small Wi-Fi module and we used the campus Wi-Fi available at that time and transmitted through this so-called Internet of Things protocol to a mobile phone, to a computer, etc. Right? And completed the kind of a full wireless system. Wireless system in the sense the output is wireless. So this part was done by them. I should say the idea was created by them and it was done by them. But the entire product becomes so attractive now, become very attractive now, right? So that is where I'm always encouraged to work with B.Tech students because they will give some state of the art. They will give us back some state of the art techniques, right? Now here is the entire prototype that we have developed. You can see the seat belt. Then there are some electrodes on the seat. This infrastructure is present in any lab. We had electrodes. We had electronics, the processor, board. Then DSO. You can see the waveforms. These waveforms are also now transmitted through IoT to a mobile phone. Mobile phone can be seen over here. The real-time mobile data. This is also shown on a computer. Right? This computer need not be placed here. It can be placed in the next room or elsewhere. But just for taking the photo, we have placed a mobile phone laptop along with the experimental setup. So these were again nice results given by our B.Tech students. So we were getting good quality ECG signals from different electrode configurations, and the algorithm chose the best of these ECG signals and estimated heart rate. Again, you can see that the heart rate is very close to the estimated heart rate is very close to the reference ones. So again, this proved the efficacy. More importantly, the scheme is it's not about the efficacy; it's more importantly about the novelty in terms of the application as far as the application is concerned. Right. So just summarizing this work, so there was two different ECG configuration developed. One was developed on a steering wheel, and another was one was a sensor fusion approach, which was developed on using on a seat belt and a seat, and both gave good results. And we had also shown the capability of the scheme to act as a drowsiness detector, right? So please understand that whatever the summary I have given in this slide number 58, right, was entirely carried out by unofficial project using with the help of a internship students. Two internship students worked with me. So I think I say if they can do, everyone can do. I feel, right. I mean, the only thing is that we have to do some kind of hard work even after the regular, 9 to 5 or 9 to 4 curriculum is over. We have to do some kind of we have to open up the labs, make it work, and we have to a little bit run around, right? We may have to work in the little bit in the weekends, but we have to manage different things, right? And if you can work as a team, you will get team skills, etc. So this was a very motivating experience for me, and this actually prompted me to take more number of B.Tech students. Even today, I'm working with many B.Tech students. More, so this was kind of a very good experience for me, and I feel that it was a good experience for the students also, because these one of the students is working in a very reputed company in India after getting campus placed. Another student is doing his doctoral studies now. I think he got into after B.Tech, he got directly into the doctoral program. So basically, I feel that this project would have helped them a lot, right? Because they continuously worked for about 1.5 years with me and produced these results. So now they are in good positions, if you see. Right? That is again another take home for them. Right? So these are some of the publications which came out of this work. So we had got one publication at IEEE International Measurement Society Measurement Technology Conference. This is actually the best conference, annual flagship conference of IEEE Team Society. So we had another very good paper which was published at IEEE CMI 2016, which is again a technically sponsored conference from IEEE Team Society. The last paper over here was again published in IEEE annual IEEE conference of EMPS Society, right? So we relatively got very good output based on these studies also, right? So I mean, like I will ask the conference organizers about the time, because I think I have exceeded the time. How is it? Sorry,
Yes, sir, we have exceeded the time a little bit.
Yeah. So anyway, I have just completed one case study. This was my initial case study. So I feel, okay, this study would have given you some kind of an exposure. So I have two more interesting cases to tell. Probably maybe on a later time, at some environment, we'll discuss on that also. So one final point is that, okay, you if you work hard, you will get, and if you have the right attitude, you will get the results. Next important point is to summarize the results, consolidate the results into a thesis. So as I mentioned, when you write the thesis, you should always write the thesis, write the contents, write the flow as if a third person will understand it, right? You should not write the thesis from your perspective. It should be from a very broad perspective, right? You should give a proper introduction. You should discuss the motivation very clearly. You should discuss the objective very clearly. Then you should discuss the organization of the thesis. Then you should divide your work into maybe 2 or 3 technical chapters. I suggest my I always suggest my B.Tech students to have 3 technical chapters. I mean, except for introduction and conclusion. So apart from introduction and conclusion, at least there should be 3 solid technical chapters. I mean, it can be made even within a 4-month program, 4-month duration. So once then you should be able to write it properly. I mean, whichever tool, whether you are using LaTeX or Windows, Microsoft Office, it doesn't matter. You need to write it properly. You have to draw figures properly, plot graphs properly. You have to cite the previous work properly. See, there are a lot for a thesis writing. It's, I mean, we cannot. It is I may need another 1 hour, so at least. But it is not. But please, that is not possible now. But you please understand that at least you ensure that your thesis is well written in terms of technical content, in terms of how you stitch the different works that you have done, in terms of referencing, in terms of preparing the figures, in terms of plotting the results, in terms of drawing the inferences, right? In terms of preparation of bibliography, right? In all counts, it should be looking like a proper document, which you yourself can use later, and it should also serve as a guideline for all your future college or college mates, right? So prepare a very good thesis, and of course you should also learn to present well, right? Okay, thanks from my side. That's it for the day. So in case if you have any queries, we can address it.
So dear attendees, if you have any questions or queries, please put it in the chat box as all panelists. So we have one query that could you please share the other case studies through any means after this program? We may need to work on this later.
Yeah. We'll work on that later. We can share it.
Okay, thank you, sir. So dear attendees, if you have any questions, please post in the chat box. We can wait for a minute to look whether there is any questions raised. Okay, sir. Can you hear me?
Yes, I can hear. I can hear.
Yes, sir. I'm having some difficulty in adding you as panelist, so I have unmuted you.
Okay.
Yeah.
Join.
Yeah. My this one background for listen.
So if there is any question, please forward it. That is.
Sure. Currently, I don't see any questions in the chat box or Q&A box. So I think we can move to the next thing. Sasha, are you there?
Yes. Thank you so much, sir, for the wonderful and interactive session. Now, I welcome Mr. Adit, Chairperson of IEEE PES SBC SCTCE, to deliver the vote of thanks.
Is not there.
that it?
Is there any problem with the audio, or is admute or?
I'm sorry, Adit was having some network issue in his area for the last 1 hour.
Oh.
I think that was the problem.
So,
Unmute ചെയ്തല്ലോ ഇത്.
Yes, but he's facing some network issues.
so, okay. In that case,
Yeah, let me take over the session.
Madhu,
Yes, sir.
so I think
Uh,
questions are there. I will just wind up by saying vote of thanks. Okay. So
Okay.
it has been a nice session, as we had 2 sessions, and Anoop sir has touched almost every aspect of doing a quality project, right from having a group work, and how to find one project, how to find a relevant project, and finally he has guided to do it in the perspective of getting jobs also. So he has covered almost every aspect of the set of the issue in the limited time, and it has been a nice session. And in fact, I want to add here that we approached him in a very limited time. Still, he agreed to deliver lecture, and that was a very. We are thankful to him for accepting this invitation and joining us here to deliver the lecture, and it was actually helpful to the students. And I thank everyone who participated here and who coordinated the activities, also the student volunteers, various SPs, and with that thanks note, I wish to end the proceedings. Thank you again, sir, for for joining us for this session. Thank you, sir.
Thank you. Thank you, sir.
So good afternoon, everyone. On behalf of IEEE SCTSP and IEEE SBC JCET, first of all, I would like to thank all of our chief guests for the session, Engineer Asgobi sir, for his presence and kind words. Thank you, sir. Next, I would like to thank Professor Deepa AK for joining us and facilitating. I would like to extend my gratitude towards Assistant Professor Satish VS, as well as unfortunately, he couldn't be with us today. I would like to convey our gratitude to our resource person for the day, Dr. Anoop C S, for being with us. Last but not the least, I would like to thank all of our delegates assembled here for the session. Thank you.
Everyone. So with that, I think we can conclude the session. Thank you.